Hello, and welcome to the WeAreDevelopers live web dev day. I'm very excited about this because for the first time, I actually don't have to fake knowledge, but I can actually talk about the things that we're going to cover today. First of all, this is an event. It's not an in-person event, so it's not that tricky like a normal event would be, but we still have a code of conduct, which you just saw. It's actually available for you online as well to read up. What that means is just be nice to each other and don't do anything that might make other people feel bad. This sounds very glib, but it's very easy to actually offend people without realizing it. And most of the time, people will not know that you actually you will not know that you offended them. And there's a lot of things you can do. So we have a policy here that we're not allowing for any sexist remarks, any racist remarks, any isms of any kind to a degree. And the thing is, if something happens and somebody says, oh, I don't feel good about the thing that you said, there's just one way to react to that, and that is to say sorry and to learn from it. There's actually there's no excuse for these kind of things. There's no like, oh, you're a snowflake or something like that. Just make sure that you're actually not annoying other people and you're not offending other people or hurting them in their feelings. So this is what a code of conduct is about. And I think we all can agree that this makes sense because as soon as you've got a certain amount of people together, there needs to be rules. So with that, let's go to the big change that we have this time. I took a look at the live program that we had in the past. It was always like long talks, 45 to 50 minutes. And then we released them later on our platform. We released them in the newsletter. And a lot of people don't watch them because they're too long. So the first change that we have in the live format right now is that we're going to have shorter talks. So all the talks are half an hour tops. And then I do a longer Q&A with the speakers afterwards. And if there's no Q&A, we do a few breaks in between as well. So that might give you a chance to have another coffee, do a bio break, or whatever you want to do. But normally we should be covering the whole day until like the early afternoon with talks and also with Q&A with the speakers. The other big change is that today we announced that there's going to be 5 talks, but we're only going to have 4 because Salma could not come because she had a problem with her family. So sadly enough, we can't do that. Hopefully we will get a chance to invite her some other day again because she was a Code 100 winner and she was a great person to actually talk to. And I was very excited about that talk. So hopefully there will be some other way to get that talk in the near future when everything is sorted on her behalf. The other bits that we have is that we're not only giving presentations at these live days now, but we also want to make them more interactive. So you can use the comments and you can use the chat system here as well to comment on things. Please use that to ask questions for the different speakers as well, because without them, I have to come up with questions all the time, and that might not be the nicest thing for the speakers as well. And we do this for you. You should get your answers with the problems or the ideas that you want to have here. The other bits that we do is instead of having just talks, we also have interactive sessions. One of these interactive sessions is a Did You Know session. This is at 12:44, 45 every single time when we have these events. And this is just a Did You Know, like there where we show some tips and tricks. We show maybe some new technologies that are coming out that you can play with right now and you haven't thought of yet. This will normally be in a video format, but there will also be a follow-up blog post where you can see these things, and it's going to be collected on our Code 100 on our DevRel webpage, where you can see these quick tricks as well. You might know this from the newsletter. When the newsletter, we also have these quick tricks every single time. So this is something similar, but in a video format, and you can actually take a peek and play along if you want to as well. And the other bit that I was wondering about was like, why don't we bring Code 100 and live together? Last year we went on a tour in different cities and did Code 100 events in person, and that one worked out quite well. But it was also very tiring for us and very expensive and very tricky to do. So we thought it actually makes more sense to actually do that online. So in every Code 100, in every WeAreDevelopers live session, we're going to have 2 options for you to become a Code 100 champion and join us for the final at the World Congress next year in Berlin again. So the final will be the same that we already have, that you can take a look at code100.dev, where you can see the video of the after show, what it would look like, and we also will compete for the big prize there. But to qualify for a Code 100 challenge, you can actually come to every one of these live days and a few of our newsletters where we're going to have online versions of these Code 100 challenges as well. And you can take part and become a Code 100 champion that way. In our case here, this is at 11:45 today here live, where you can then use a Slido quiz and do a multiple choice question. So you got a chance of 4 in 1 in like 5 questions. So I'm not good at math, so you can guess what, even if you don't know anything, you can get a chance to get through. And one of those is a pseudocode question where we show you some pseudocode, and you actually have to guess what that functionality does and give us that. There's going to be 30 seconds for each of these questions, or 25 seconds because I'm weird. And then there's 60 seconds for the pseudocode question, and that's going to be at 11:45. And then at 13:45, at 1:45, we're going to have a Code 100 challenge as a code challenge. And this one is not live because, of course, you're not here. But you get until Monday to actually solve this and actually send the result in a form. So every single live day, 2 of you have a chance to become a Code 100 champion, and every few newsletters, there's another person as well. So we're going to have probably a lot more challenges next year at the Code 100 final than we had this year. So that's about it for today. There's a lot of stuff happening right now. So the first speaker that we have today is Lucien, and I just want to bring him up on stage and we start talking, and he's going to start presenting at 10:15 as we promised people as well. So Lucien, how are you doing?
I'm fine, thank you. How are you doing, Chris?
I'm good. Was supposed to be in Vienna, but as with the flooding right now, it didn't make any sense to fly there and actually be in time at the office. So I didn't want to chance it. So I'm staying in Berlin. I'm on the 3rd floor, so I'm kind of safe. But it's absolutely bonkers what's going on there. I saw the pictures of Poland and Czech Republic, and it's absolutely atrocious what's going on there. Yeah. It's really, really sad. But and at the same time, we got fires in Portugal. So I don't know what's going on with this world. Oh, I know what's going on with the world, but we haven't treated it nicely. So what do you do? You're a principal consultant at Rockstars IT. What do Rockstar IT do?
Yeah, good question. We're an IT company in the Netherlands that are the biggest thing we do is we deliver brain as a service. So if a company needs some IT engineers or one or multiple IT engineers for the project, they can actually call us, and we can chat about if we have some rock stars that are a match for your project, and then they can help you out.
Okay. What are the things that people ask for the most? I think when I talked to the German companies, when I looked for a job after leaving Microsoft, a lot of it was like really old stuff like Fortran, COBOL, and these kind of things, because all the original developers on these machines actually are now going in pension this year.
Yeah.
So nobody maintains those things. Is this something that you also get requests for, or it's more modern technologies?
No, it's more modern technologies, because one of the things is we have defined the stacks that we want to work with. So it's either Java or .NET for the backend, and for front end, it's either at the moment React, Angular, Vue, or CSS, and people that actually enjoy the web platform as a platform and want to do stuff with that. But we steer away from the older technologies, because also the people that we have, our consultants and our engineers that we have, they rather do cool new things than maintaining the old systems that somebody else built, who is now going to enjoy their pension. So
Well, I mean, it would be interesting to have a rock star that rocks Fortran. It's kind of like it's kind of
Yeah.
in the name. So how many people are you, and how many projects do you normally juggle?
Right now we have about 650 people working at Team Rockstars IT. Most of them are IT engineers, but we also, of course, have people in the office helping out. What we try to do is really have the person, so the rock star at the center of our company. We, as the people around it, work for them and with them, and together with the rockstar engineer, we try to deliver the best we can. We work for numerous larger and also smaller companies in the Netherlands, but we try to expand to Western Europe. But that's still a goal to reach. So at the moment, the focus is the Netherlands. And like I've said, we have smaller companies that employ 10 people, but we also work for larger companies that have 10,000s of people working at their company.
One thing that was that we had a lot of news about in the job market is that that machine learning and ChatGPT is really digging into the market of freelancers, and basically people that normally you would get a freelancer for, and people say like, okay, I can ask ChatGPT to do it. Do you see that as well? Is there a decline happening right now, or is it still a thing that people try it out and then mess it up and then you have to fix it?
Yeah, that's a good question. I think we see both actually. So for some companies, we see that ChatGPT and AI are really big things that are being invested in quite a bit. I think there are also a lot of possibilities there because someone needs to tell the AI what to do, and not everyone is a product owner that can really write down what an engineer needs to do. So you learn also from those new environments on how to do your job even better. But we also have some clients that say, well, at the moment we don't want any form of AI involved in our IT department because we either don't trust it or we can't share the information that we use, and we still are figuring out where to draw the line. So we see both actually happening, and it really depends on the client.
Well, much like developers use like co-pilots and these kind of things, or others can't because they're actually not allowed in their company to do
Yep.
it. Like the code can't be indexed. Do you have few high security customers as well, that basically where you cannot touch the code and you have to give it back? That was always my biggest frustration when I worked for an agency. I had to restart everything from scratch because the code belonged to the customer and not to us. Is this something that you also have to deal with?
Yes, code is never ours. It's
Oh God.
always the clients. So you hire us to do something, and when the project is done, we go away. You keep the code. It's your code. You need to figure it out. Or of course you can call us back up again, and we'll figure it out for you. But in the end, we're, like I've said, we're brain as a service. So you can pull in some of our people to do the heavy lifting, or to think about the heavy lifting, like me, for example, as a consultant. Um, I'm more hired to do the thinking about the heavy lifting, and then luckily somebody else who actually understands how to code can pick it up to yeah, to put it in the code of the client. But like I've said, it's their intellectual property. It's their code. It's never ours.
It's an interesting one. I mean, I love being consultant to a degree because oftentimes the customer knew the problem. They just basically didn't trust their own engineers to tell it to them. They had to hire somebody expensive to tell it to their managers. So is this still happening, that you're just like, yeah, we know this is broken. We just didn't get the funding for it until an outside company told our boss that it actually is broken.
Yeah, and
Is this still the broken system that we're dealing with?
I have seen that happen. Yes.
Cool. Well, I mean, the good thing is that if you keep making mistakes, you just basically get a follow-up business with that. Like you just keep a few things in
Ah,
that are broken, and then you
that's
fix them
job
later on.
security.
Oh God. Okay, today you're going to talk about API first UI components, and
Yeah.
what does that mean quickly, just before you get started?
Yeah, the gist would be well, I really enjoy design first APIs, so that you sit down with the team to think about how are the different systems going to communicate with each other. And I thought, what if we do the same thing, but then for a UI component? So if you have a design system filled with components in your component library, and for example, a completely different team who is consuming those components, how would you what can you do to change the communication layers and to think about how can we improve the collaboration between those teams, and what if instead of building the component and then telling your other team, well, it's done now, you can start using it, we think about the API of the component together and then start together.
Excellent. Well,
All right.
without further ado, we're at 10:15. People
All
will
right.
want to see you and talk about that. So I see you in half an hour tops, and I will come in between and say, like, when you're too late,
Yeah.
kind of stuff. So half an hour from now.
Okay, then. Well, then I better get going. Thank you all for joining. Please, in my presentation, I have a few links. At the end, I have an overview page with well, quite a few links. I've also added a small camera on that page when it's the best time to take a screenshot or to take a picture. But if you don't want to, and by all means, you don't have to, you can also visit the presentation itself on api-first-ui-components.netlify.app. And before I start, I want to start with thinking about a few questions that I had in the past, but also still have present day. And that's the question. Well, the first is, who writes UI components? So, well, I have my hand up already on screen and now on camera as well. But from time to time, from time to time, I write a UI component. And every time that I write a UI component, of course, I need to know what's its purpose. Why is it needed? Is it new? Is it an extension on something else? Have we done this before? And why does my project always need a new and improved date picker? But then again, if we think about that date picker, it is used somewhere. And if I'm on the design system team at a company, I'm probably not on the web team that consumes the design system. Maybe I am. Maybe I have control over all the UI that I'm working with, but there are also possibilities that you don't. And what happens if you're on the web team and you need a new component, a new UI component? What are the steps that we need to take? How do you ensure that the component that you get can do everything that you need it to do? And in that process, I've seen that, well, we had a great idea, and then someone needed to build it. And that also meant that that ticket will be, for me, put in the on hold lane, because I had to wait until that component was created. So it takes a few sprints, and then after a month, it's part of the new version of the component library, and I can start using it. But is that, and first thing that I need to do then is to think about, wait a minute, what was that component about again? Oh yeah, we had a date picker and we extended it, and now I can add a range in between two dates. Right, that's excellent. What was the API again? What did I need to process? There was something with the property that changed. There is a lot of additional thinking because I had to park this ticket for a month and then start over again. What if we can change this thought process? And that's actually what I wanted to talk about today. And it's a thought process. So, well, let's start off with, oh, that's a yellow screen. Let's start off with introducing myself. Hello, my name is Lucien Immink. That's my face. I'm a principal consultant at Team Rockstars IT. And like I've said to Chris, the thing that I try to do in my work is to help out people, help out companies that have a specific issue that they can't solve themselves. But I also want to help out people in our industry, help them to not make the mistakes that I did in the past. Like, For example, create a design system without any formal feedback, and at the end of the day, had a beautiful design system with a large component library that did exactly 95% of the things that people that used it were expecting. But that last 5%, well, that took a little bit more extra time. And yes, Clippy, we shall move on. So for today, what I want to talk about is the first and most important thing, I think, while we're working with people is communication. Because we need to communicate our needs and our thoughts. Then I want to briefly touch upon the principle of a design-first approach. So instead of diving into the code, we'll think about what we want to build before we start. Then, of course, I need to touch upon web components. Well, I say, of course, I'll get there when I get there, but trust me, web components are, for me, a big part of UI creation. And because we're going to talk about web components, I also want to talk about the thing called the custom elements manifest. And that's actually the main course for today. And I end with something that, well, I'm not entirely sure how I should pronounce it, but let's call it AG. We'll get there. So communication first. That's the most important thing. And actually, while we're at it, we're doing it right now. We're communicating in a form where I am describing a thought process and you're listening to it. And the reason why we can do this is we have a contract in between, and that contract is called, in this case, English. I've learned English in high school, and because I know the basic rules of English, although it's not my native language, I know that I can at least try to communicate my thought process to you. You have learned English either because it's your native language, or you learn it in school, or you learned it somewhere else, but you have the ability to understand what I say because we have made an agreement on what certain words mean. The same goes for computers. Here the contract is called an API, an application programmer interface, where in a document or in code, it is described how to get data from a server or how to send data from a server. Depending on where you are, either as a front-end developer or a back-end developer or a full-stack developer, you need to know about the contract in order to understand your constraints. If my contract says you need to send a number and I send a string, I can understand mostly afterwards, but I can understand why it failed because I didn't adhere to the contract. But if I do adhere to the contract and it still fails, I can probably safely assume that it's either a failure of the receiving system or the contract itself. And this got me thinking, because this works so well for so many systems. And this really got me thinking, what if we do the exact same thing when we're using, on the one hand side, a website, and on the other hand, a design system or a component library, which is part of a design system? If we have all those different components, all those different Lego blocks with which we can build the website, can we actually build the website that we need, or the web application that we need? And for this, well, you have multiple approaches to get to this contract. So one of the things that you can do is you can write your component and make it part of the contract. Sounds legit. The other thing that you can do is called design first, where instead of starting with building something, you get all the stakeholders together and you tell them, this is what we're going to do, or what we want to do. We're going to develop a date picker. So that means that the provider of this date picker, the design system team, can share their knowledge that they already have about the different subcomponents that are part of the date picker. But also the consumers, so in this case the web team, can be involved and can tell, well, it's nice that I need to that you want us to send the date as a string, but I already have the date as an object. Maybe we can also implement to send it as an object, because that would mean that I have to do less. So both the providers and the consumers of this component, of this UI component, can talk with each other to really think about what is the best way to communicate. What is our language? But also involve the roadmap. So in this case, the product owners. What if that date picker indeed needs to have a range in the next sprint or in the next PI? If we already know what's coming up, we can take that into account all before we start coding. And if I'm thinking about UI components, I'd love to have them framework agnostic, independent of any framework. If I'm going to start a new UI component in 2024, I'd rather not have a dependency on React, Angular, Vue, or whatever. And the reason is that what if in the near future we don't use React, Angular, or Vue anymore, but we still want to use the same UI components? What if the company decides that we're going to switch? That would mean that I need to rewrite my code base to use the new UI components or the old UI components. But if we have a UI component that is framework agnostic, this wouldn't be the case. So the business logic, that's something completely different. But the UI logic, well, there are tools in the world that you can use easily that are framework agnostic. And one of the things that I saw a few years back is an upgrade deadlock, right? So the design system team had a dependency on a UI layer framework written in React. I thought it was 16, and that was incompatible with React 17. But the application needed to update, but couldn't if you want to use the UI library. And it's a hard sell to tell people that are not into this industry why you can't upgrade your application and why security is becoming a risk. Should security become a risk due to a UI component? Well, in my humble opinion, no. So this is where web components come in, because they are independent of any framework. With a web component, I have a template where I can write my UI. And in my UI, I can define different slots where you can host light DOM elements in your encapsulated component. I have a shadow DOM where I can make sure that my style and my functionality doesn't leak to the outside world, meaning that I'm fully independent. But I can share my UI components as custom elements. And the best thing is, a web component is a part of the web platform. The web platform, if that's the goal of my application, means that it runs anywhere. I don't need to install anything to be able to use a web component. So with web components that look like this on line 4, so it always has a dash. That's rule number 1 for web components. A custom element always has a dash. So hello dash world. And in this example, I've also added the property, and this is how HTML has worked since the start. And that's also very good to remember, because if we look at the web API or web components API in particular, we see that we have properties or input, right? So I provide data. I have events that I can listen to where I receive data or updated data. This is from the perspective of the web team. From the perspective of the UI component team, you get properties as input, and you need to send out events in case something happens that they need to act on. You get the slots for the placement within the component. So if you want to have a specific header in your date picker, you can add a slot that says slot name is header, and the web team can add that header themselves while you are in control of the placement within the web component. And using CSS and CSS variables, we have all the control we need over the styling of both the component, but also making sure that the styling is only part of the component. So I don't need to think about the context of the component while the styling is controlled in the component. The custom elements manifest is a way of describing the API of a web component. And there are many tools that need a machine readable description of what a custom element is. Like, for example, your documentation viewers, your design tools, your linters, your IDEs. And we can help these tools, or we can help these environments by providing information about our web components. And the custom elements manifest is an effort to bring together those tool owners to standardize on a common specification. And I think the most important word in this sentence is standardize. Because if we can use this standard, we'll get a lot of things for free. Right. While I was creating this presentation, I had a writer's block because I wanted to do this design first, right? So think about my API before writing any form of code. But is that also the way that I want to work? Because I can either write my custom elements manifest, which is a JSON file. I'll show you an example in a minute. But I can also, from the other hand, write what I call a skeleton component that describes the API but doesn't do anything else. And then use that skeleton component to generate the custom elements manifest. If I write the custom elements manifest first, I can also generate the skeleton component. So for this presentation, because it's visually way more awesome, I will use the skeleton component. But if you want to know more about the way the custom elements manifest work, well, I can briefly show you an excerpt of a custom elements manifest where I have my custom element, my custom element hello-world, where I can add, for example, CSS properties. So per property, I need to define my description. So that's just for us humans, that we understand what it's about, the name or the variable itself. And you can optionally define a default. What if you don't specify the value? Well, then it's either black or red, depending on which CSS variable we were talking about. The same goes for the events. So CSS and events, you probably guess, yeah, the same goes for the attributes, so the input. So we can describe both the input, the output, the slots, everything inside this JSON file, which is quite human readable, but it's still quite tedious to work or to start with, especially if you haven't done it before. You can also, or what is also defined in the custom elements manifest is what kind of custom element it is. So what kind of web component are we talking about? In this case, and in my examples, I will use lit, but you can also use other web component libraries. But let's talk about a skeleton component and what it is. And thanks, Clippy. I never would have guessed that you don't have any clothes. Let's talk about a skeleton component. What is a skeleton component? Well, in my case, a skeleton component defines what my properties are. My events, my slots, and my CSS. So I get a starting point for a web component that has all the properties, all the events, all the slots, and all the CSS variables that I need in order to build or consume the component. In other words, I need to define my API. So what you can do in the custom elements manifest, we can do that in code as well. And if we do it in code, well, the most important things that I will highlight here, and like I've said, I'm using lit, but you can also use something else. If we're using lit and you want to know more about lit, there are a lot of great online resources about that. I'm not going into how to write a lit component at the moment, but I want to highlight a few things, starting with my styles. And what I see here again is that I have a variable text color and a variable background color. And I have the default black and red, but I don't have any form of a description yet. I can do the same for my inputs, the properties, and the events, dispatch event in this case. And you can, and this is working code, right? But to help me out as a human, I also add a render function that will just display an overview of what is happening. So I have an overview of all the different CSS variables that I have, then a list of all the properties that I have, and they are automatically changed and they're reactive because they're written in lit. It's reactive and you can use it directly whenever, wherever. So if I write this component, I have my API. And with this API, both teams, the web development team and the design system team, can start to work. But like I've said, I'm missing some information regarding the context. What is this text color? Well, for that, you need to start to document your skeleton component. And you can either do that at the start. We're using JavaScript doc, JavaScript doc in this case, which is also a standard way of writing documentation in code. You can add it at the top. So I define a CSS property that has the background color, that is the variable text color with the default color black, and the description. It controls the text color. But I can also write it next to the property or event itself. So right above the property, I've written what type is the world today. There's a tool called the Custom Elements Analyzer that will walk over this code and will match the documentation with the property. That will match documentation with the event. And that's where the magic happens. Because if I run that analyzer or I have written my custom elements manifest, I can use other tools that will make my life so much easier. Tools, for example, that will generate a component that hosts the documentation that is found in the custom elements manifest. So I get a component that I can use anywhere. This is a web component. I can use it anywhere in my documentation site, which could be React or could be something completely different. But I can also use this in Storybook. And because it's a web component, it's also interactive. So I can see which properties I have, but also which events and which CSS custom properties I have. And the cool thing here is this isn't where it ends. Because a web component can load web components in slots. So what this web component does is it also loads my skeleton component. So this is the actual view of my web component hello-world with the header, the CSS variables, the attributes, and the events. And I can tweak this, right? So I can, in the source tab, you'll see the actual state of the component. But I can tweak this. I can change the property type, which defaults to wonderful to WeAreDevelopers. And it will change in the view. So I can actually see what happens. I can change my styles, make the background color blue, for example, and it changes to blue. If I have any events in my component, I can trigger that event and see what happens. So I've sent a gift or I've sent a bomb. And if this is the actual state that I want to work with in my context, well, let's head back to the source tab and, this is what I need to copy and paste into my environment, and it will tell the component, this is your starting state, right? So I have the inputs, in this case, type set to WeAreDevelopers. I've changed the background color to blue, right? This is where no, it's not it's arg. This is where arg comes in. And arg actually means automation as a gift. Why am I calling this automation as a gift? Because, well, you don't have to do anything to use it as long as you have that starting point. And the automation as a gift examples are numerous. What you get, well, I've just shown you a demo. That's what you get. I didn't write anything except for that custom elements manifest myself. I generated the skeleton component, and then I loaded the custom elements manifest inside that web component that shows me the documentation and the interactive playground. But I can also use that custom elements manifest as part of my linting and testing solutions, making sure that before I publish anything, it's API compatible with what we said. It can also be directly fed to tools like Storybook, and you get cataloging of your web components completely for free. You can also use the custom elements manifest to start to generate code or generate wrapper components if you're using React 18 or lower. You shouldn't write those things yourself. If you have the knowledge of the API, you can generate them. You can generate complete components with the API that you have written down first. You can also look at integration into your IDE. If I feed the web component manifest in my Visual Studio Code IDE, it will better help me with code completion and with validation. You can also generate the documentation sites straight from the custom elements manifest. And people have written tools for this already. This is not something that you need to do yourself. So if you want to get started, and like I've said at the start, I will show you a photo icon when it's time to make a screenshot. If you want to know more about web components or the lit web component library that I've used in my examples today, head over to lit.dev. For the custom elements manifest, you can go to custom-elements-manifest.open-wc.org. That's a mouthful. If you want to know more about the automation as a gift, the plugins, the manifest analyzer is actually the starting point of a lot of your automation, and you can hook into the analyzer with plugins, and you can also write your own plugins if you want to. If you want to know more about generating a skeleton component from the custom elements manifest itself, you can head over to my GitHub repository, where I build a generator that you can use to generate lit components straight from the custom elements manifest. The written version of this presentation is visible on Medium, and you can head over to Team Rockstar IT's Medium account to read this in your own pace. And like I've also said at the start, if you want to revisit the presentation, this is the URL api-first-ui-components.netlify.app. And yes, this would be the best time to take that picture. I'll give you 5 seconds. Right. So, looking at the time, 3 minutes left. Awesome. Wrapping up. What did I talk about today? Today, I gave you my train of thoughts regarding communication. Because you need communication in order to understand each other, to work with each other. And if we think about our API first, maybe also for UI components, and instead of writing code and then sharing the code, we think with each other, we communicate with each other about what does the component need to do and what's the best way to do it. We're using a design-first approach. And if we talk about UI components that need to be reusable, I'd strongly think about web components. Strongly. And if you are using web components, you can use the custom elements manifest to make sure that you get a lot of automation as a gift. And with that, I really like to thank you for your time. If you want to get in contact with me, feel free to hit me up on LinkedIn or Mastodon. Thank you very much.
Excellent. Well, good to hear that you're on time, and good that that all worked out. Also, shout out to Mastodon. I'm still confused about it. It's really hard to explain Mastodon to people. Like the it's not like a one-on-one replacement for the place that it become the the dumpster fire that used to be Twitter. But it's actually really cool to. But DMing people is pain. It's really not really tough to actually find a replacement at the moment. I also do you, so the article on Medium, is that behind the paywall, or is that a free article? Because is that a gifted article, or have to use one of those breaking pages that actually give you the content without it?
As far as I know, it's a free article.
Okay, that makes sense
I
then.
I hope. If not, please let me know and I'll fix it if I
Okay,
can,
cool.
or host it somewhere else, because I'm against putting things behind the paywall if it's knowledge that is so usable for so many people.
Mhm. So you're using Lit. That is basically a Google product. Is that still maintained? Because they have a. I mean, I haven't looked at it in a while because they have a penchant of like stopping things from being maintained after a while. Is that still a striving community, or is it something that is already like on farm sourcing, as I call it? So we put it on the farm and somebody cares about it.
That, as far as I know, is still a thriving community, but you got me worried now.
No, we used it inside the developer tools as well. When I worked on those, the Chromium developer tools use Lit as well. But we at Microsoft, we basically didn't want to necessarily do it, but use web components out of the box like the native ones.
Yeah.
But they didn't have all the features that we wanted to have yet, and especially if Safari was lagging behind. Do you think that's a thing that is still that people go for component libraries of other libraries rather than the standard ones because they either know that there is no functionality or they just assume that it hasn't been added?
The thing is, of course, well, depending on what kind of engineer you are, there are a lot of things, a lot of boilerplate code that you also get if you use native web APIs. So, for example, for pre-templating, DOM manipulation was, well, quite tedious to do. Same goes for the reactivity of elements, which are just the things that Lit tries to do the heavy lifting for you, but it stays really, really, really close to the web platform itself. Last time I did I gave a demo about it. I think that was last year at in the same theater, or 2 years ago. And the overhead back then of the Lit library was only 6 kilobytes. So what does it do exactly? Well, it's actually things that you can. Well, the source code of Lit isn't that big. At the end, looking at what it does, it introduced those decorators to have more shorthands regarding events, properties, and the reactivity and that kind of things. And also, and of course, the lifecycle hooks for the render function and that kind of things.
Yeah.
And of
So
course,
I mean, I mean, we're gonna have a talk right about this after event loop after this. So that's one thing that actually was a big, like a big mystery for a lot of people. So I guess that's why these libraries make sense. I'm always kind of scared about these. Like it's only 6K. I mean, jQuery only used to be 4K, and now it's a security and performance problem of the web, because we have thousands of older versions of jQuery all over the place still, and the maintainability of it was not given as much as we thought. And I thought it taught a lot of developers like really weird practices, because they're like, here's like a few lines of code that do a lot of stuff. And it actually created style elements, inline style elements on everything. And it was really bizarre that we now have to deal with this like it's easy. So that's why I'm really excited about that. You actually talked about the platform native things more, that it actually that you want that there is an insight that people are using libraries, but they actually discarding them. So do you see that a lot with your customers, that they're switching from one library to another? And what's the time frame there?
yeah, I've the company that I work at the moment, they really struggle with, well, that they're a big company and they have multiple teams working on multiple products. They want to use the same look and feel because they're the same company. One of them is using Angular, 4 of the other teams are using React. And for the proof of concept, someone was starting with Svelte. And they're really struggling with, do we need to recreate our design system or our component library? Well, I wouldn't recreate a whole design system for this, but they're struggling with, do I need to recreate the component library in both Angular and React components? So the Angular and React native components. And this is where I strongly have the feeling, well, of course, in the end, like we've learned in college, it depends. But going beyond the obvious, and that's why I'm talking about UI components in particular, I don't think that the majority of the complexity needs to reside in that layer, right? So you consume UI components to create your and combine them with your business logic to create your intricate application. That business logic, well, I would write that in whatever the team feels best, right? And if that's today, unfortunately, React, and tomorrow something else, that is something that the team can decide on themselves. But they shouldn't be pushed into a framework that they're not used to just because they want to use a reusable component.
Yeah, I mean, sometimes it's also a decision that some director came with something that they used in another company and they want to bring in, and it's like a lot of politics going on there. That's always the thing that frustrated me about this. One thing I found really interesting is that already preparing for the next talk, custom events is something we had for a long, long time on the web platform, but nobody seems to use them any longer. I worked on the YUI library back then, and we extended our components before we had web components with custom events by firing those and allowing people to listen to those. It seems like that knowledge has gone completely. Like nobody is understanding these anymore.
I read an article a few weeks back where the author really advocated that custom elements should be forgotten altogether, because there are a lot of event types already defined, and that the custom event was too ambiguous, that it didn't tell anything what kind of event it was.
Mm-hmm. Well, that's a naming convention, isn't it? Like, I mean, we said like user change or these kind of things, basically, much like we do on the back end now. So it's an interesting concept as well. The other bit that, of course, people were worried about components was browser support. But I think by now, with the latest Safari out, we're actually have the last problem solved, right? What do you think?
Yeah. I've heard a lot of I've heard people saying, well, I'm not sure if we can use web components already. I would say, well, yes, you can. In 2024, yes, you can. It shouldn't hold you back. If anything, what is holding back adoption of web components more than Safari would be older versions of React.
Yeah, I mean, there's also a thing going around right now, like about ES5 compatibility, backwards compatibility. If you should still compile your ES6 into ES5, and I think the main usage for like outdated JavaScript is still older versions of React out there, rather than like people having written it by hand. Because I mean, everybody uses their arrow components or uses TypeScript by now. So it's an interesting bit that like backwards compatibility in a language is necessary because of a library that was made to actually advance the platform because the language didn't move fast enough. So we're running in a loop here, which again is like a promotion for Chris.
I think that we're both old enough to know that we've seen this before.
Yeah, that's true. Yeah, remember Frontiers?
New shirt. Yeah. Unfortunately, my shirt wasn't visible during the talk, but I got Clippy with me.
Oh,
always.
right. Fair enough.
He's the most underappreciated AI ever. He helped me out a lot.
There's Clippy.js, which is a full Clippy integration with all the animations in it as well. I wonder how much copyright infringement is in that one. But actually, it's available with sounds as well and everything. So all the annoyance of like old Windows you can put on your website now. So that's pretty nice.
Yes. Actually, fun fact, I used Clippy.js as a web component in the presentation.
Fair enough. That makes sense.
You see Clippy talking about that he as a paperclip doesn't wear any clothes.
Yeah, I mean, that's already I mean, I don't know. Like, I mean, there was also him being unemployed and doing all that kind of other stuff. There were lots of good videos about this. But yeah, it's an interesting bit that we had this annoying helper, and now we put annoying co-pilots everywhere to just do the same thing. One last thing, I'm working with a company called Locify, and they gave a few talks at our event as well that actually do component conversion from Figma components into React and other components using AI. Do you think that is a market? Do you think that is still in its infancy, or do you don't trust it, or what do you think? Like, because I find it weird that we do componentization in Figma and then we send the designs over to somebody else and they make components out of it again. It feels like a waste.
Yeah, it does. It does. I think that well, hopefully in the end, it can be used to export your the components API again. I think that's most important. But if you, yeah, it really feels like those old code generation tools where you got something that looks 95% of what you needed to be, and then you spend 95% of the time figuring out what exactly you need to change in order to get the last 5%.
What you see, what you
But
get.
I didn't use it personally yet, so it's my hunch. I could be wrong. I hope I am, because it would save a lot of time for a lot of people if it does
Cool.
work.
Well, I mean, you're off the hook. Well done. We're gonna release the video then in the next week and cut and put all the things in there that are actually there. We might actually link to the Medium thing as well. Like, what I normally do is, like, when I have lots of links, I actually put them in a gist and just show the QR code. That actually helps a lot of people to actually see it there, rather than like having to. So that's a really good little thing to do. But well done, and thank you so much for being part of this again. And I'm quite sure we see you again.
All right, thank you, and enjoy the day.
Will do. And next we're gonna get our next speaker in, Christian ampersand OUML RZ, and he's going to talk about the event loop in JavaScript. So my team is putting him here, like, yay, lots of toys. So that's already good.
Hi.
How you doing?
Good. Thank you. Really enjoy being here again, because this was I think this was 2 years ago, was my first talk I ever gave at like an online conference. So it's nice to be back again.
So what do you do now? I mean, everybody who gave a talk here has a very massive career after that. So what happened to you after you gave your talk?
Nothing really changed that much, but what I really started to do to give much more conferences also in person. So this is what I really enjoy, and it's really nice to have the possibility to also talk to also exchange with other people, especially like at conferences. It's always like this vibe of the people want to learn something, and it's always really nice. Yeah.
Mm-hmm. So you're a full stack developer.
Yeah.
Everybody says that. But it says that you're working in Java, Kotlin, TypeScript, and JavaScript. That's a lot of them, and they're very different. So what do you do day to day? What's your normal job like?
It's like I'm currently I'm a contractor, so but I do really, beside like Kotlin, this is more like at some teams where I currently work are using Kotlin, but I'm mainly creating web applications. So I create really from the backend from Java with SQL database until the front end, everything. So really I use this on a daily basis, and I really enjoy that I have the possibility to do that, because if you only work like in the front end or back end, it's always hard to develop these feature complete things. You're always responsible only for the small part. So I really enjoy to be able to really do all the stuff, really, like also in my job, not only like in personal projects.
Yeah, otherwise it becomes teams, and you have to do a lot of handover and a lot of communication, exactly. And it's of course for scaling important, and for making sure that you become an expert important as well. But like getting the 90% of the way there, it's basically an opportunity to do all of those things. So you're going to
Absolutely.
talk today about the event loop in JavaScript. I remember there was a long time ago a Google talk about the same thing, which went into massive detail, and it was quite an interesting one as well. So by what was his name again? Damn it, I forgot his name right now. Doesn't matter. We're gonna go back to it.
Yeah, there were some really cool ones, and I tried to make this a little bit less in depth and less in the browser side of things, but more like also like how the runtimes implement this. And I tried to make this as simple as possible and to easy understand as possible, because I think it's a topic that is often not really, though not many people talk about it because they think it's way too complicated, but in reality it isn't that complicated, and I try to show that with this talk.
Yeah, and I mean, there was also the problem that in the past there was wrong implementations in browsers that you had to fix things, and that gave it a weird vibe that like, okay, here's the standard, but it's not really doing it that way. So hopefully you be able to sort people out today. So I see you in half an hour, and we're going to do a Q&A about it. So without further ado, let's get started.
All right, thank you very much. So as already mentioned, I will try to show you in the next like 25 minutes. It will depend how fast I will talk about what the event loop is in JavaScript. So because I think it's much easier to understand than many of us think, especially because it has like this vibe of it's hard to understand, but I think it isn't that hard. So let's give you a quick introduction about myself. I already talked a little bit about myself. My name is Christian. I've been working as a software engineer for the last 14 years. And in the first 7 years of my career, I only did like backend stuff with Java, and back then also heavy Java EE, JSF for the people who maybe have also used this. And then around 7 or 8 years ago, I switched over to full stack because then Angular 2 was released. So since then I do daily work as a full stack developer. So TypeScript, JavaScript in the front end with Angular mostly, and the back end Java, Spring, and all the normal well-known Java libraries. I also am a frequent speaker, so I also really like to, on the side, to give some conference talks, learn from other speakers, learn from other people. And when there is time, I also am a trainer, so I also give trainings about Kotlin or, for example, or about testing. And so if you need anyone to get a training, just let me know. And recently, what I really enjoy doing in my spare time too is I started to create some content about TypeScript, so really advanced TypeScript stuff. So you can find everything about me, about the links of YouTube and so on my website. So you can visit type.rocks. There is the link to GitHub, to my YouTube, but also, of course, to LinkedIn, and if you want to send me a mail. So just visit over there if you want to get in contact. All right, so what will we talk about today? Before I really enjoy doing live coding. So at most, as often as I can, I only do live coding in my talks. But in this case, we have to do some theory first. So we have to dive a little bit into what is really the event loop in theory and how it is implemented. So the first thing we will talk about is what is the difference between an engine and a runtime. So we then will see also why we need the event loop, because we will understand how a runtime works. And we also will talk about what the different parts of the runtime are, because we will need that to understand how the event loop connects them. And then, of course, we will go back into some coding, and we'll see how we can use the event loop to our advantage or even disadvantage in real life coding. So the first thing we have to talk about is the difference between an engine and a runtime. So often when we talk about JavaScript, we hear these terms of engine, and then we hear runtime, but there is a clear difference between these two. The engine, and this is important to understand, implements the ECMAScript standard. So this means that if you have, for example, ECMAScript 2023, this is a standard, a specification which each runtime, which each engine has to implement. So this means, for example, if you have V8, or which is used from Node, or SpiderMonkey, which is, for example, used from Firefox, they have to follow this specification. Now, the important part is that the engine does not have additional functionality like set timeout, fetch, and so on. So let me show you this in reality here. What I have here is, and you can also visit this website, is a Mozilla SpiderMonkey at GitHub.io. This is a web page, a website which you can use to check how the SpiderMonkey engine works. So because this was compiled to WebAssembly, now we can see here this is like the default demo, and we can see here we get the output from our JavaScript engine from SpiderMonkey. But what happens now, if let me remove this here, and let's say I want to use set timeout. We will see here that we get an error because set timeout is not defined. This is because, as already mentioned, this is not inside the ECMAScript standard. If you check in the specification, you will not find something like set timeout or fetch or something like that. This is only available from the runtime. So this is this additional functionality a runtime provides. The same thing is also, of course, with, for example, process, which does only exist in Node or in server-side languages, server-side runtimes mostly. And of course, also window is also not available here because this is implemented in the browser runtime. So this is important to understand that an engine is like a subset of a runtime. Now, let's go back here. But what does now a runtime provide? The important part is that a runtime is like a host for the ECMAScript engine, for this engine we have. It integrates it, and on top and around it adds more functionality. So for example, it adds web APIs, it adds functionality to handle the DOM in the UI, file access, and so on. And the important part is that these restrictions, that there are no restrictions in features for the runtime, because you don't have basically a specification like the ECMAScript standard. There are like de facto features which every runtime should have, but it's not mandatory. So for example, for a long time, we did not have fetch inside of Node or any other runtime which does not run in a browser, but fetch was only implemented by the browser. So, and also what we need here is this runtime. Every runtime needs to implement its own event loop, because this is also not part of the ECMAScript standard, because the ECMAScript standard only defines the core of JavaScript basically, but everything around there has to be implemented by the runtime. So why do we need the event loop? Well, we all know that JavaScript at its core is single-threaded. So we have, for example, here and on the slide, we have a console log start, then we have a really slow call function call, and then we have the end. And the problem with this is when this really slow call is synchronously, then this would block the UI. So let me show you what this would mean. So I will switch over here to my browser, and I have here a really small example, because what we are doing here is we have two buttons here. We have this fast button. When I click it, the background changes, and you can see here, as long as I keep the button pressed, this will stay red. When I remove it, the button will get released and is no longer red. Now we can see here this happens really fast. Now what happens here when I click on the slow button? If I click this and I move the mouse away, you can see the button is still red and the background did not change, because in the background is a blocking function running. So let me show you how this blocking function looks like. And we can see here we have a function which does something really simple. We have this while here, which just does many times execute this I++ in here, and this takes some time. And because of that, during this time where this function is running, nothing can update, because the UI here is completely irresponsive, because we only have one thread in JavaScript, and it is blocked where we click on this button and something is running in the background. This is why we, of course, need JavaScript to be asynchronously. So we need to send off a task, and it has to be handled somewhere, and we take then the response and go from there, but we don't wait for this request response to finish. Now, the event loop is responsible for exactly that. It needs to orchestrate the execution of these tasks. So when should something which is done, for example, from an HTTP call, be executed? Now, to understand how the event loop works, we have to also understand what the parts of a runtime really are. So what is like the concept of a runtime? What parts needs every runtime needs? So what is important that a runtime works? Now, we will go through all these parts, and we will start with the call stack. So the call stack is simply explained, you're currently running code. So when you, for example, have in your application, you have a console log first, second, and third, then the first element in this call stack will get executed, the console log. Then when it's done, it will get popped off the call stack. The second function will get called. It will then get popped from the call stack. And then the third one will get called. So this is sequentially, and it will just execute everything which is inside this call stack, and it will do this single-threaded, so one after another. This is where the code lives, which currently gets executed. Now, there are, of course, other parts, like there are two different queues which are used to keep the results of certain requests until they are ready to being executed. And one of these queues is the macro task or callback queue. The important part here is this is a first in, first out queue. That means that if you push something into this queue and you add something after that, the thing you pushed in first will also leave the queue first, so it will get executed at first. So it's like when you have a normal queue, the one which came in first will also leave the queue at first. Now, what do we store inside this queue, or what does the runtime store in there? The runtime stores the result of these web API callback or event handlers in there. So we will see later how this exactly works, but as a baseline, it's important to understand that this queue is needed to store the results of our asynchronous calls, for example, from web APIs, and to store until we are ready to execute them, to take them and execute these functions and then call into our call stack. The important part here is also that it's a lowest priority queue. That means that from all the parts here in the runtime which carry the different tasks, this has the lowest priority. In stark contrast to the microtask queue. The microtask queue is the same kind of queue, a first in, first out queue. But the main difference is that the microtask queue, what it's allowed to be in there is really restricted. So you're only allowed to put in there the results from promise handlers. So, for example, when you have a then, catch, or finally, the results from them will get put inside this microtask queue. The same thing happens with async await handlers. So when you use these wrappers for promise-based APIs and use async await, these also get put in there. We also can do this manually. We can add something to this microtask queue by using queue microtask. This is a function which is available, which allows us to add manually a task to this microtask queue. Now, recently, in the last recent years, we also got a new API, which is called Mutation Observer. This also can be used to. This also listens for changes in certain mutations we do, for example, in our DOM, and the results from them will also get pushed into the microtask queue. Now we see here this is called microtask queue, and the other queue is called macrotask. So what this maybe already implies is that macro tasks are like bigger tasks and micro are like smaller tasks. So what the runtimes do is they always prefer the micro tasks over macro tasks in priority. So when there is something in the microtask queue, it will always get executed before the macro task. Now, I know this is maybe a little bit technical, but I think we'll see this later how in code, how this will work. Now, but what do we put into these queues? And as already mentioned, there is another part of the runtime. This is the Web or C++ API. And what the Web C++ APIs are the things which are provided from the runtime. So for example, as mentioned, fetch, set timeout, set interval, and all this stuff is provided by the runtime. So there are, of course, asynchronous APIs and synchronous APIs. Now, synchronous APIs would be, for example, document query selector, local storage, set item, for example, the clipboard, and all this stuff. These are synchronous calls, so they will not be put inside of the task queue. These queues are only responsible to handle or to store the asynchronous stuff. But how does this work? Well, let's say we have in our code a set timeout. This set timeout has a delay of 20 milliseconds, and we then say, hey, after these 20 milliseconds, we want to have a console log of hi. Now, what happens is we call this. So this gets popped from the call stack, and we then call our set timeout function, which is implemented, for example, in C++ or in the language which the runtime itself has implemented that. And then what this function will do is, or what this implementation will do is, it will, in this case, create a timer and will say, okay, I will wait 20 milliseconds. And after this is done, I will put this arrow function, so this result, into the task queue. So what it will do is it will here say, okay, the timer is done. So I will have to take this set timeout arrow function we put in there and move it into the task queue. So at the end of the task queue. And only then, when this delay is done, so when this 20 milliseconds are over, only then the result will get pushed into the task queue. This is an important thing to understand because the task queue or all the queues contain only the result functions of our calls, so of these web API calls, for example, or our promise calls. Because, for example, when you have a fetch call and it's still waiting for the response, it will not put anything into the task queue until it gets a result. This is important to understand for later. But we can see here, we put the things we have from the result into the task queue. But how can we now make sure that this task queue gets emptied so that we call the results from there? This is exactly where the event loop comes into play. Because the event loop is basically a really, on its most baseline, it's a really simple thing because it only has one job. It has to take care of executing the different tasks from the call stack, microtask, or macrotask queue. Because what it will do, and I tried to show this in this diagram, what this does is it checks first, is the call stack busy? When the call stack is still busy, when there are still elements on the call stack, so for example, there is a for loop still running, while there is still something on the call stack, nothing will get evaluated and executed from the other task queues, from the microtask or from the macrotask queue. Only when the call stack is empty, then it will first check for the microtask queue and will check if there are any tasks in there. If there is a task in there which is ready, it will then move this task into the call stack and then the call stack will execute it. And this is why it's called the event loop, because it does this all the time. It always checks, is the call stack busy? No, then it will check for the microtask queue. And only if the microtask queue also is empty, then the macrotask queue will get checked. And this is what I've shown prior with these priorities, that the macrotask queue will never get checked as long as there is something in the call stack or the microtask queue has some tasks in it. So this is really the only thing which the event loop is responsible for. Of course, when we have the browser, then there are also things like repainting our website. But especially for runtimes, for example, for Node, this is like on its base, on a basic level, what the event loop needs to do. Now, of course, this is really a little bit technical and theoretical, but let me now show you how this works in code. So what we have here is we have a simple index.js file. And let me show you here at the side, we have also the same diagram as before so that we can, when we execute the code, also check what really happens here. Now, let's say we have here this set timeout and we have an arrow function and we say here we have a console log and we say here timeout like this. Now, what we can do is we say here we have also a console log like this and we say log. Now, when I save this, I could now run this from the terminal. But I created a VS Code extension, and it also exists for NeoVim, which you can use to see the results of your JavaScript or TypeScript code right inside of your editor. It also works for Bun, for Dino, and of course for Node.js. So what we can do here is I can just run my code here, and we can see I get the result of my execution here right inside my editor. But we will now say I'm only interested here in these 2 lines. So I will add this comment here, and let's rerun this. And we can see I get log and timeout. Well, this isn't really helpful because we don't see in what order it gets executed. But I can just enable this here using show order. And when I click on it, we can see here I get the order in which these 2 values were logged. Now, of course, we also have here this timeline, which we can step through, so we can see the result here. Now, let me close this because we have a little bit more space with this, and we can see the console log was executed here first on line 6, and only then the one on line 3 was executed. Why is this? Well, let's figure this out. This set time, we have our call stack here, right? The event loop checks, is this call stack still busy? Yes, it is, because we have a huge amount of code in there. And the first thing it does is it says, okay, I have this set timeout call. So what it does is it calls the web API or the C++ API, and it tells it, I have this function here, which I want to execute after 0 milliseconds, because when we don't add a 0, this will have the 0 as its delay implicitly. Now let's add this here. So what we now can see is that this gets executed after our log here. Now, because why is this? This, as I already mentioned, this gets called. Then our function, our web API or C++ API tells, okay, after 0 milliseconds, I will put this result here, this function, into the macro task queue. Because, as already mentioned, set timeout and everything which is not promise-based will be put into the macro task queue. Now, this is put into the macro task queue. Then the event loop will check, is the call stack still busy? Yes, it is, because we still have this here running. So the console log is still in our call stack. So there are still elements in there. So it will not check for a macro task. But as soon as we have logged this, we will check again, is the call stack busy? No, it's not. Are there micro tasks? No. Are there macro tasks? Yes, this timeout here, this console log is waiting, so it will print it out. So this is how we can also, why this set timeout works in our cases when we, for example, develop an application and we call set timeout, that this gets called at the end of our executed code, because it will only call this when there are no more resolved promises or our call stack is empty. So let's now add something else. Let's say we have a promise here, and let's say we have a resolve, and we say here resolved. Now, promise resolve here, what this does is it just immediately creates a promise and it immediately resolves it. So let me show you how this works. Let's run this. And we can see here we have this resolved promise, which is of course resolved, but this was called and out and printed out before our set timeout here. Again, why is this? Because this promise resolve here is put into the microtask queue. So again, the order will be like this. The call stack will be executed. So the set timeout gets executed. Then the event loops, then our API creates this function here and puts it inside of our macro task queue, because the delay here of 0 milliseconds is immediately reached. But then we still have elements in the call stack. So what it will then do is it will execute this promise resolve. The result from this promise resolve will get put into the micro task queue. Then the event loop will check, is there still stuff in the call stack? Yes, there is. So we have this console log here. And as soon as the call stack is empty, what then will be done is it will get checked, is there something in the micro task queue? Yes, there is, because we have this resolved promise here. So it will show the result of this, will evaluate it and put it in the call stack. And only then it will put the result from our set timeout into our call stack. So this is important to understand, that when you have a promise which is resolved at the same time as for example, a set timeout or another callback, then the promise is always at first place, and only then the callback based or the macro task queue will get executed. Now, of course, this is only the case when the promise is already ready. So what we can do here is we can go in there and let's say we remove this here and we say we take this fetch here and we say http google.com. And what we then say is we have our then, and we have this result.status. And what we then do here is we add this question mark here, and let's run this again. So we can see here now the order is different, because we can see here the console log here is still first, of course, but then the timeout gets executed, and only then the fetch gets called. The fetch gets evaluated and put into the call stack. Now, why is this? Because we have seen prior that only when a task is ready, it will get put into the queue. Now, this fetch here takes more time to evaluate, to execute, because it needs to call an HTTP request. It has to do an HTTP request and wait for the result. And this, of course, takes longer than 0 milliseconds in this case. And because of that, so the console log will get checked. Okay, the call stack will get checked, and we see, okay, we have this console log here, which is still available. So it will get executed. Then the event loop will check if there are elements in the microtask queue. But because this one here takes longer than, for example, the 0 milliseconds, it will not be available in the microtask queue. So the only thing which is available currently then is this macro task here, which gets put in from the set timeout. So the set timeout, so this console log will get printed out. And then after 100 milliseconds, for example, this will get put into the microtask queue. And then it will get evaluated when the event loop next checks for a microtask. But it's important to understand that only because we have a promise in here, this will not get evaluated before a callback all the time, only if they are in the task queues at the same time. So when they both would be at the same time in the task queue, in the micro and the macro task, then of course the fetch here would have the advantage because it would get executed first, evaluated first. But if there is something not done yet from a promise, then of course it's not in the task queue. Now, the problem here is with these micro and macro task queues is that we can starve the macro task queue by adding new micro tasks all the time. So how can we do this? Well, let me show you. Let's create a function here. And we say this is a function, let's call this function queue again. And what we will do in there, we will call queue micro task. As you have seen in my keynote, we can add a function in here, which then gets executed when we call when this queue micro task gets executed from the event loop. Now what we will do is we will say console log here, and we say queued micro task called. And what we then will do is we will just call queue again. So when this got executed, we just call queue again. Now we just call queue again here, and let's save this. And for this, I will open the terminal because in there we can see much better how many times it gets executed. So I run this here, and we can see here, I will stop this. We only have queue microtask here as a result. This timeout here will never be called. Why is this? Well, let's see what happens here. We have this set timeout, then it gets put into the macrotask queue. So it's available when there is nothing more to do. Then we have this queue again. What this queue again does, it queues another microtask. So there is now an element inside of our microtask which contains this arrow function here. Now, of course, we can't execute this microtask right now because we have this console log. So this gets executed first. But when then the event loop checks that the call stack is empty, it will then execute the thing in the microtask queue, which is this arrow function. This arrow function will do the following. So basically, what will get evaluated is like when we would call this and put this in here. Then this is then put onto the call stack, and everything else isn't available anymore there. So because of that, what will happen is this queue again will queue another microtask. So you maybe already got it, but what I want to show you with this is every time we call this microtask implementation here, this function, it will queue another microtask. And because of that, we will never reach the point where we don't have anything in our microtask queue. So as long as we do that, the set timeout here will never get evaluated. So we have to take care that we do not starve the macrotask queue by always adding new microtasks into our microtask queue. So I hope it's a little bit easier to understand now how this event loop works, because I think at its most basic level, this is what we have to understand: that we have a call stack which is evaluated always first, and only if it's empty, the event loop will then check if there are other things to do. It will first check for the microtasks, like promises, like we have with our queue microtasks, mutation observer, or with async await. And only if there are no elements in there available, then it will switch over and use the macrotask queue, which is used, for example, for all the web APIs, which are callback based, and will then evaluate the results in there. And a result only gets put into these queues when it's a real result, so not when it's still an ongoing request and it does an HTTP request and the result is not available. So this is everything I had to show you in code. And now I want to thank you for listening. And this would be my talk about event loops. If you have any questions, please just send me a message on LinkedIn or on Twitter, or even you can send me a message on YouTube. And if you want to stay in contact, please visit my website, type.rocks. And yeah, I would be ready now for questions or for a little talk with Chris, I think. Thank you.
All right. Well, I mean, that's good. So yeah, it's an interesting bit where basically the people don't, where it's hard to understand what the difference is between browsers, events, and the engine event itself. So it was good to get an overview of those kind of things. Do you think that people coming from other development environments are more clued in about this because they have different debugging practices? Like when I worked on the developer tools for the browser, I basically wanted to get people to start using breakpoints, to start using the look at the stack, look at the order in which things were generated. But instead, people put console logs everywhere, and they do them inside timeouts, and then wonder why they're actually not coming in the right order. So, do you think there is a lack of knowledge about debugging in the JavaScript space that we should be pushing more for?
I really think so, because I think it's me coming from a Java background. There was always a really easy way to debug this stuff, and it's you have your IDE and you add this breakpoint, you run your code, and it's all basically there. And for the browser, it's also working really nicely, but then you have to in earlier days when we had to configure Node to be able to debug, I think it was a little bit harder. And I think also the thing is that many people, I think, which join into web development, which join the web development community, maybe come from different backgrounds than just, for example, more technical backgrounds. And I think there it's much easier to use than just something like console log to see the results immediately. And I think this is, as you mentioned, this is a little bit overlooked, how to debug stuff properly, because I think it could really save you so much time, because when you just use console log and you add another one and then you check what's the result, and sometimes it's different, it's really, I think at first glance, it's easier than just set up a debugging environment. But at the end, it takes so much time from you. Absolutely.
Yeah, I mean, we now have log points as well, which I kind of think it's fun that in a third-party app you can set right-click and log when this happens kind of thing.
Yeah.
It was also great to see that you had SpiderMonkey in there, because when I worked in Mozilla, I worked on the other Jaeger monkeys and the ones that we had before, and there were a few multi-threaded ones that we were thinking about as well, using Servo back then, and Rust implementations. So it's interesting to see that kind of stuff. You can also look at, of course, V8. That's also open source. If you want to play with that. And I mean, Chakra, which is now not used any longer by Microsoft, but it was an interesting concept of also allowing time travel debugging in JavaScript. But then we realized people wanted Chromium, so they actually moved the browser to that one as well.
Yeah.
So when it comes to like debugging kind of environments, like as a freelancer, you'll probably get like a lot of like different environments to work with as well. Do you start your own environments, or do you sometimes go to companies and actually have to deal with what they've been setting up? And if that's the case, how many different versions of Node did you have to work with, and what were the confusion points there?
Yeah, there is really, it's always interesting how this. I mostly use the tools they provide because it's also easier for them when I try to show something then that they know that they know the environment already. But it's really interesting. Like sometimes you have to like the things are wrapped for. Often like the many companies switched over from like Java and, for example, JSF to use Node or Angular and all this stuff in the front end. So there is so much stuff left in there. For example, they have like these Maven builds which wrap around which create then like a jar which contains then all the Node stuff and all the JavaScript stuff. So it's always interesting to see what kind of it's always interesting to see how they even can debug this, because sometimes it's not even really possible to do that. But I have to say, in the last years, I really enjoy. And currently, I'm like since 2.5 years, I'm at the same project, and they are always pushing to the newest Node version. They also like really let the developers figure out the best ways to work with your code yourself, with the code yourself, or how to debug this stuff. So you basically have all the possible tools already available. And then this is also not often the case that you can just install basically everything you like. But I think also the management also understood that this makes us much faster and much easier and enables us to be much faster and can produce better code. So because I also heard from friends which work in completely different environments where they also have like these external these external libraries which they can't debug because they're like minified and they don't know what happens in there. It's like a black box. I personally, I'm really glad that I don't have to worry about this.
ChatGPT is actually really good in unminifying stuff. It's really bizarre how well.
I have heard about this. Yeah. It's really it looks to be it can really be crazy.
It's always been like an umbrella made out of paper. I mean, the idea of minifying some JavaScript and then making unreadable. I mean, it has to be turned into viable code for the engine anyway. So it actually is not helping much. The same way that CSS compression doesn't make much sense anymore with HTTP2. It doesn't give you any benefits of what we used to have in the past. One thing that people asked was the name of the extension that you used to run it inside VS Code. Was it Wallaby or?
No, it's something I've written myself. I can maybe show it shortly. It's a TypeScript worksheet. You can just download it, and then you can just run it inside your VS Code. Exactly. Yeah, and then you can
And don't worry about the Bitcoin miner that is actually in there as well.
No. It's the only thing it does is it basically wraps your code in that the results you gets put into like a JSON file, which then and my extension knows what on which line it has to show it. This is all, and it's just I'm using it personally too, and I think for me it's really nice that I don't have to always go into the terminal. And for example, when I want to try something with Bun or with Dino, I don't have to run it with Bun or with Dino or check if the imports are working, because this is all done by the extension.
Nice. Yeah, I used Wallaby before when I did demos. I actually did the evaluation of the JavaScript directly in the editor as well, so you didn't have to use anything else. Or there's another one called Code Runner, which actually allows you to actually highlight any code and it runs it. It does like PHP, Perl, Ruby, whatever you want to do.
Nice.
So that's a really interesting thing. I mean, that's what I love about VS Code, that it's such an open ecosystem that you can actually write extensions that you get access to the Monaco editor in it and actually inject things into it. So I think it's really powerful to get that kind of.
Absolutely.
problem in there. So in terms of like what people do wrong, what do you think is the biggest problem that people have with events, and where do they make the biggest mistakes? What would you love people to stop doing?
I think the main thing which I also sometimes have to do, but I don't really like this, is just put in anything like, for example, this set timeout. Just put it in there and then see, oh, okay, now it works. And yeah, I will leave it as it is. I think it's important to understand why does things work, because I also did support. I also were like mentoring some people in some junior developers in an early company I was, and I always told them, okay, now it works, but we have now to figure out why it works, because it's not enough that you just know, yeah, okay, I have used this set timeout or something else, and this does now what I wanted to do, but you have to figure out why does this work like that, because if something breaks, you don't really know why it's no longer working. So I think it's like this. It's not only with regarding events, but always just think about why stuff is working or not working that you write. For example, also with this set timeout, so many people are using it, and I sometimes also use it, and I sometimes also don't know why it exactly worked that everything else was done prior, because there is like this magic from these frameworks like React or Angular, which does just stuff behind and you don't really see what happens. But whenever possible, you should really try to understand like the core of your language, because I think nowadays with ChatGPT and stuff, it's really easy to generate code which works fine, but if there is an issue, you don't really know where the issue is. So in my opinion, you should always still know a little bit what the core of your language, how it functions, so that you can, because I think many people also tell, yeah, the ChatGPT or the AI will take away our jobs. I think it will only take away the jobs from people which do not know enough of the core stuff, because when you basically can be replaced by someone who writes better prompts in ChatGPT, I think then yeah, maybe it will replace you. But when you still am the guy that, hey, this is no longer working and you can fix this, I think you will be in the future even more needed than now, because we will create so much code from ChatGPT which is not really that well maintainable.
I mean, as Simon Willison puts it, ChatGPT is like the weird intern that knows the manual by heart but doesn't know what it does.
Yeah,
and
exactly.
It's been trained on it as well. I mean, that's always what drives me nuts about when you see like W3C schools or W3 schools, or when you see like also Stack Overflow, that people always upvoted the answer that was the simplest but not the best. That actually explained the how but not the why. Like there was a lot of there's a lot of code that these machines have been trained on that is very ineffective but looks very simple. And I know so many when I saw old components that people build where it's like a 20 millisecond set timeout because the rendering of the component wasn't quite done yet. And then they basically just left that in for years to come. And it's a memory problem, and it's also a performance problem as well. The other big thing is that when it comes to loop animation, like game animation and these kind of things, that people still use set timeout rather than request animation frame, because that request animation frame gives you insight into what the browser does right now. It actually works with the browser, whereas set timeout always works against the browser. And I think that's something that you should always be aware of when you use a set timeout or a set interval.
Absolutely. I think this is it's really important. It's really interesting what you mentioned with the Stack Overflow, because you also see that when you ask ChatGPT to, for example, I want to have a function which just filters something a little bit more complex, it will most often go for example, also in JavaScript, for loops, because like these questions or these answers from Stack Overflow are way older than like the like with filter map and so on, which is available in JavaScript forever, but it will still go for this for loop because there is much more code which was written that way and maybe also upvoted in Stack Overflow much more. So it's also like stopping people from adopting newer frameworks or newer ways of doing stuff. I
On new
think, yeah.
functionality in the language
Yeah.
itself. I mean, I just
Yeah,
had
exactly.
in the last newsletter, I talked about flat map, and I didn't know about it either. It's just ridiculously good. But the problem, I think, with for loops is also that most coding programming courses started that way. Whereas a
Yeah.
while it actually is easier to understand for a human. But the other side of that story is like if you go completely clean code in JavaScript and you just do one chain after another, you're actually creating a lot of for loops that you don't know.
Yeah.
Like
Yeah, exactly. Yeah.
there's a performance problem in like using
Yeah.
all the new functionality as well. And I remember when I worked on Chakra, we looked at the code of the web, and every for loop that actually had the iterator read and indexed at the same time, rather than like, for example, the when you loop through an array, it actually had the end of it as the array length rather than just caching that one. The
Yeah.
engine itself started caching that for you. So JavaScript engines undo a lot of very bad code for the
Yeah.
web, and that is basically 20% of the engine by now or something.
Yeah.
So it's really bizarre that that we still get these unoptimized functionality because it seems like the very obvious thing to offer to people.
Yeah, and the thing is, sorry, yeah.
Well, we're almost out of time, so
Yeah,
we
for
gotta,
sure.
we gotta go on with the Code 100 challenge. So
Yeah, for sure.
it's great to see the talk. We're gonna edit the video, and it would be cool if you want to talk, if you want to do a write up of your extension. We can put that on the blog as well. So let's talk about that one because
Sure, of
people
course.
seem to be interested, and we can go from there.
Really cool. Yeah, yeah, gladly we'll do that. It was lovely
right.
being here. Cool.
Okay.
Then thank you very much.
See you soon. Bye-bye. And now is the time where it's going to get interactive, and I hope everything will work out because it's the first time I'm using Slido. So we are now going to get to the Code 100 challenge, where you can take part online with your mobile phones or on your computers and actually take part in the Code 100 challenge that we're going to show in a second. And the winner will actually go to Berlin to the finals. So hopefully a lot of people will start taking part in that. And we can actually start running over there and actually start sharing. I will share my screen and work on it as well. So if we now can get the overlay, yes, you see this QR code down there? No, there. So if you scan that one, then you can actually start using that one in your mobile phone, or you can also go to the URL that is actually in the chat, and then we can go and start using that one. So I will go to the admin interface here on my machine and share my screen as well for you, because I will take part in that one as well. And of course, I'm going to not pick the right answers because that would make it too easy for you. So we can share that screen here, and you can see my Code 100 WebDev Day screen here, and you should have the same on your machines now. And if there's nothing else to do, then I can actually go and start the poll. All right. We have 2 users, we have 3 users, we have 4 users so far. That's not much. Hopefully there will be more coming in. All right, 6 users, 7 users. I'm going to get started when we have 10 to 50 users. Before that, it's going to be a weird thing to do. It's also pretty unfair that Andrew is going to be in here because he's actually one of the Code 100 winners of last year as well. So it's going to be interesting to see how he's going to fare this time. So 9 users, 10 users, and more coming in. So that's good to see. Christian is also in there. So hopefully there will be something about events. I'm not quite sure, but it's going to be interesting to see. 11. Yeah, 4 more, 12. One thing to remember is that we are actually not, I don't know your name here, and there's no obvious names because I don't think there's ever been anybody here called FJKD. So if you're a winner, what we need you to do is take a screenshot of the winning thing, that basically you are the winner, and send that to me at chris@wearedevelopers.com. so we can actually get started. Then you can actually validate that you've been the winner. So please don't do that in Photoshop. Just do a screenshot of it, and we then get a rest of information for you and start covering you on the blog and on our social platforms as well. All right, we got 15 people in here, so I think that's an okay thing to do. So let's get started with the quiz. As said, 25 seconds each question, and the coding, the pseudocode one is a longer thing going. So I am now starting the quiz. Which of these was invented most recently? XHTML, CSS, JavaScript, HTMX. 15 seconds to go. I'm not going to pick any because I don't know, or it might not make sense to do that. All right. And the answer that most people had was HTMX, and that is also the correct answer. Which means the winner right now, the leaderboard so far, is that Andrew Taylor is the leader on the leaderboard here. We don't see that right now. That's bad, but I can tell you because I'm seeing it here. Next question. Which of these are not a deprecated HTML tag? Big, multicol, copyright, or iLayer? Oh, that's going all over the place. People are voting in all kinds of directions here. That's really cool. It's amazing how much is in there in HTML that we don't know about anymore. All right. Most people said copyright is not a deprecated HTML tag, and they're correct because copyright never existed. Next question. Which language was the majority of WordPress built with? JavaScript, Ruby, PHP, or Go? Voting is going on between two different languages here, so that's interesting to see. And the correct answer is the answer that most people chose. It's PHP. Which now brings us to the next question, which is the pseudocode question. You can zoom that here if you want to. Given the following pseudocode, what is the return when you call find important letter with WeAreDevelopers as the input? And I'm going to zoom it for you here as well. And you got 4 options to choose from. And that is now the bigger one to actually go for. This has always been the interesting bits at the live sessions where people were very confused about pseudocode. I remember the first time I wrote this, I started writing pseudocode, and then I realized I can just write it in JavaScript and ask ChatGPT to turn it into pseudocode. That makes more sense than coming up with random stuff. Let's see what people are going for. Okay. All over the shop. That's interesting to see. 9 seconds left, 8 seconds left, 6 seconds left, 5 seconds, 4, 3, 2, 1. And the correct answer, let's close this one here. And the correct answer was actually E, because this is just a fancy way of saying like, take WeAreDevelopers and count which one of the letters is the most one in there, and that's actually E, because the other ones don't repeat each other at the same time. Which brings us to the leaderboard. And we got 2 winners. We got Christian Wirtz and Andrew Taylor as the winners. Question is now like, do you want to become a Code 100 winner as well, Christian?
Yeah, I mean, if it's okay for everyone, then yeah, why not?
Okay, cool. Then it's easy to actually know which the winner is because they're easy to contact. And yeah. Andrew Taylor, I mean, you can come back again as well. Don't worry about it. So, you know what? Seeing that there are so many people in here, Siegfast, the third winner. If you can contact me and give me a screenshot of the poll that you've actually taken part, you can also be one of the winners here. And I'm happy to actually have 3 people come to the finals in the WeAreDevelopers World Congress in July next year. And with that, I thank all for participating. So that was actually the Code 100 challenge, the first one. Later on, we're going to have a challenge that we show you what you need to do. And then you actually have to have until Monday to do it offline and then fill in a form to send us the information out there. And then we get winners from this direction as well. So again, Zeke, if you email me at chris@wearedevelopers.com, then I know who you are and take a screenshot of what you've done. And then we can go from there to go further in the environment here as well. Which brings me already to the next speaker, and not to his talk yet, but we have Andrei here. And Andrei is going to talk about something that made me very, very excited to see, because I'm a big fan of regular expressions. And I know I'm weird, but I started with Perl, and then I got to PHP, and then I got to JavaScript. And then I realized they're actually all different and kind of like implementing regular expressions and have different engines, and it's quite some fun thing to do. And a lot of the challenges that I wrote for Code 100 were simple to use were simple to solve with a regular expression, but I found that many new developers have never heard of them. And do you think that's a good? Do you think that's an assessment that you found as well? Like,
yeah, frankly speaking, I will be touching base on all of this during my presentation because, I mean, it will be on slides, but I can give some small tip. I was studying in the university what exactly I'm going to talk today, and I didn't know how I can use it until like 15 years after university. So this is very fun, to be honest.
Yeah, when I wrote my JavaScript book, I basically the regular expression chapter was the one that took me the most time, just to ease people into it and to get them to understand, to not write expressions that are too greedy, to actually understand where the issues are. And that was even before we got into like emoji and these kind of things that we have nowadays, where you have to think about text encoding much more than you did before. But before we actually get into the geekiness of it and bore everybody to death out there, so you're a principal software engineer delivery hero. So what does that mean? Like, how big is your team? What do you work with day to day? What kind of challenges do you see?
Yeah, thank you for this question. I mean, talking about my team, talking about another principal engineers in Delivery Hero, it's maybe 50, 60 people overall around the world. We are not working closer to each other. I'm working more with my tribe, I would say. And my daily work, it's meetings. Meetings from the morning to the evening, to be honest.
Yeah, I think that's a thing you have to deal with when you get into a principal level. I mean, I was principal PM in Microsoft, and that was basically meetings within meetings with teams on the side and like other things and working with other departments. But I think it's quite cool to actually geek out on a talk like that as well and go back to your roots and actually do something different.
Yeah,
Where you
to
based?
be honest, sorry to interrupt you. To be honest, I prepared this call this presentation 6 years ago.
Oh wow. Okay, so time to upgrade it.
No, it's upgraded with new learnings.
That's good. What made you choose that topic?
It's also will be in my presentation. It's a full story.
I'm giving things far too early there. I think it's one of those things where you can write very clever, very unreadable code, and once you know how to do it, it's a very powerful thing to have. But there's a general fetish in the developer community to write code as short as possible, and sometimes it can actually backfire. But it will be interesting to see if more people after your talk actually start understanding regular expression, because there's lots of memes going out like, okay, it's incomprehensible. It's like, it's people making fun of it rather than using it. So it will be interesting to see if you can change their mind a bit about it.
I hope about this.
So is your team watching? Are the people are actually coming in there as well, or are they working instead? So you basically, I'm going to do the presentation now, you do the work.
I'm in Berlin. It's lunchtime already, but I hope they will postpone it for 1 hour.
Okay.
And yeah.
Cool. Well, you can always order food on Delivery Hero, right?
Yes, always. This is what I did.
Fair enough. How long have you been actually a principal? Was it a big change for you to go from like lead to principal, or is it just something that I'm of a certain age, I have to do it?
Oh, it's a really good question. So far, maybe a year and a half in this position, and talking about it wasn't natural for me. It's absolutely new experience and absolutely different tasks I need to handle every day. So yeah, it's like I'm not coding anymore. I'm more designing systems and talking to people.
Yeah, that's what I kept talking about when people were saying like which jobs are going to get taken over by AI. And the more you get into promotions as a developer, the less code you write. You actually, the more you review other people's code and write best practices and write structures for other people. So the skill set of evaluating code and looking at code and the quality of it has to go down much further right now. Like junior developers will generate a lot of code with AI and will have to have the skill set of reviewing code rather than writing code. And that's a challenge that we as a market we have to face right now.
Yes, exactly.
Cool. Well, I'm not going to take time away from you. So I already tried to actually predict what you were saying, and I was right. So hopefully there's going to be interesting bits in there for people. So please, please, please tell us about pattern matching and regular expressions. Half an hour from now.
Cool, thank you. Let me to start my presentation first. Yeah, and hello everyone. Thank you for giving me this opportunity to present. And this presentation will be how regex works actually. And one thing wasn't touched during the initial talk. I am backend engineer, and I'm here on more like front-end conference. But why? Because regex they're everywhere, and everything I will be talking here applicable to everything in like front-end world everywhere. So let's get started. Let's a bit. We've already talked about me. I'm Andrei. I'm a principal software engineer and delivery hero, and maybe that's all. I can nothing to add to this. And I know, guys, you have a chat. I can't see this chat right now, but if you can write there, do you like lead code? Do you like to use lead code? And this is answer to one of the questions, how I can kind of found I need to do this presentation actually. So it was a lead code 6 years ago. I would get bored. I started to learn a new language. For me, it was Golang. That's why I have this Gopher memes right now. And yeah, I faced one not complicated but interesting task in lead code. And this task written here. So this is regular expression matching. And you have a string, you have a pattern, and you need to implement this regular expression matching mechanism, which supports dots and asterisks. Dot matches any single character, and asterisk matches 0 or more than previous element. And also it has some limitations, so you need to use only AZ and so forth. So they also give you some examples which you can use if you like TDD, as I do like. So you can write tests before you start implementation, and you can use this as an input. They also do some explanation why, for example, this our pattern is 1A, by our input string is 2A. That's why it doesn't match. So your implementation should return false eventually. Another example already with asterisks, and it means so you can match more than one A in this case, and the same input gives already true with this regular expression. Another one also true. This one also true, but I like this one because it's complicated to figure out what is wrong. I always fail, but wrong is this. Oh, let me start doing this. Wrong is this I in the middle, so there is no in the pattern, that's why it doesn't match. So what I did in my implementation 6 years ago, I created like 4 tracks. For different cases, we already face it while I was reading the description, going through examples. And these were cases like pattern. So we have character we want to match and validate if it's matching. We have repeatable pattern for cases when we have the asterisk, for example, this E, and any pattern, just a dot, and repeatable any pattern. So I created these 4. And what I did next, I was going through the our pattern and creating linked list. So why linked list? Because the current one points to the next one, and then if we match our input string correctly, we can go to the next one and try to match the next one. And it was working fine. So I have some example like this one. It was matching perfectly. I have another example. It also works, and here is very tricky because first we need to match first A and then only start with this repeatable pattern of A. So everything works. Kind of I solved the task. And yeah, another example, I solved the task, it works. But the question, did I create a masterpiece? And unfortunately, answer to this question is not. And why? Always when you build something, you need to ask yourself, how are you going to extend it in the future? Is your solution scalable? And my favorite example, this one, this is a regular expression to match email. I found it in the internet. I was looking for something very, very ugly. And I found it, and how I'm going to implement with my approach this, on my opinion, is possible, but how long it will take for me. So I started to think about, okay, regular expressions, they're everywhere in our life, in any programming language. And this problem solved for many years. So the question, how it's being solved? And I started to Google, and I found this very interesting article from Russ Cox. If you're not familiar with Golang community, Russ Cox, up to the 1st September this year, he used to be a tech lead for Go programming language project for the 12 years. So this is a super smart guy. He knows what he's writing about. And he wrote this article like in 2007. So everything going after this is inspired, and my very free interpretation of the article I read like 6 years ago. And let's get started. So what is the regular expression itself? Regular expressions are a notation for describing set of character strings. When a particular string is in the set described by regular expression, we often say that this regular expression matches the string. So the simplest regular expression is one single character, and except special characters like asterisk, plus, question mark, some parentheses or pipes, each character matches the self. And we have some already mentioned meta characters like asterisk, plus, or question mark, which call it repeatable operations. So you can repeat. We already faced it in my implementation, right? So, and the thing we are going to use today to work with regular expression, call it finite automata. So this is another way to describe set of character strings. And it's also known as a state machine. Wow. Rename scene it, and it brights with a new lights, right? And we also will use automaton or machine in our presentation. So a simple example here is a machine recognizing the set of strings matching by the regular expression represented here. So we have the initial state. If we have A, we can go to the next state. If we have B, two Bs, we can go to the next step. And we also have this loop because this is like parenthesis, and this repeatable meta character, and we also have A. So we can represent regular expression with finite automata. And yeah, if you like more visual representation, it's here. So yeah, we are matching A, we have some input here. We go to the next state, we matching B, we go to the next state, we matching again B, we again phase B, so we can go back in the loop, and so on and so forth until we kind of finally match our string. And I already mentioned this. Doesn't this sound very familiar to you? To me, yes, because in university, I spent maybe 1.5 years to study these automates, these finite automates. I had a huge course, but no one never told me it can be used for regular expression matching. And this is maybe answering, so that's why maybe young people don't know much how it works, because no one told them, like, yeah, there is something you were studying for this for a long time, maybe. So if we go through them, subset of this finite automata is a deterministic one. And deterministic one means that at each possible input letter lead us to at most one new state. So if we stay, let's start with a simple example. If we stay here and we have input of A, we have only one way to go through them. And any other character, for example, B. If B, we can go anywhere, so only one way. The same is here. Even if we have two arrows here, depends on the input, we can go either here or here. We can go two directions simultaneously. And another subset of finite automata, non-deterministic, and different to the previous one. You see, we moved the arrow here, and in this case, we have more possibilities to go with the same input. So we have B at this step, and we can go with this B here, or we can go here to continue the loop. So the machine, okay, I already said this. And in this case, when we have such situation, when we can go to different directions, to different paths, we need to let machine to guess which path is the best for us. And NFA matches an input string if there is some way it can read the input string and it can follow the arrows of machine. So in this case, if we have multiple lines, it will go any of them if it can match. So if we go through them, sometimes it is convenient to let NFA have arrows without corresponding input characters. And why? Because if you look at this and remember the previous one, like this looks exactly as a regular expression, isn't it? Because we have A at the end, and we have two B's in the loop. Amazing. So for us, it's much more convenient as a human to look at this, read it, because it's more clean. So regular expressions and NFAs turn out to be exact equivalent in power. Every regular expression has an equivalent NFA and vice versa. There are multiple ways to translate regular expressions into NFAs, and the method described here was first described by Thompson in 1968, so very long time ago. The NFA for a single expression is built up of partial NFAs for each sub-expression. And this is what we usually do in software engineering with any problem. You just take the big problem, you split it in small one, you solve small problems, and then you combine the result to have some more big and sophisticated. So nothing new for us. And if we want to describe NFA, how it looks like, so this is our NFA for single matching regular expression. So just we have initial state, we have some character to match, and we go to the next step. The same we have for NFA for concatenation of our regular expression. So we have two characters and each of them goes after each other. So we can concatenate it and have like flow of our regular expression. If we talk about alternation, in this case, we have a new state, which is not kind of present inside the regular expression, but the state is split. So we can have two options to go, either E1 or E2. And for example, if you talk about regular expressions with the loop, this one, so we can go either with unlabeled empty path, with unlabeled arrow, or we can go and try to match whatever we have in this state. And here we have finally loop. So we expecting 0 or 1, or 0 or many appearance of some element in our regular expression. And in this case, we either just go further without trying anything, or we go in the loop here to trying to match whatever we have. Another one, you know, this with plus, which means one or more. So yeah, after this, first of all, we need to match the first character, and then we can go further or we can go in the loop. Okay, we described our NFA and we have clear matching between regular expressions and NFA. So we have some elements of regular expression and we have some elements of NFA. So converting the new state in the diagram, counting on the new states in the diagram above, we can see that this technique creates exactly one state per character or meta character in the regular expression, excluding parentheses for sure. Therefore, the number of states in the final NFA is at most equal to the length of the original regular expression. So they're kind of matching each other. Just as with the example NFA discussed earlier, it is always possible to remove unlabeled arrows, and it is also possible to generate NFA without unlabeled arrows. These unlabeled arrows only convenient for us as humans for visualization. For machine, it doesn't matter because all of NFAs I showed in the previous slide, they are equal. So now we have a way to test whenever a regular expression matches a string. We convert regular expression to NFA and then run NFA with the string as an input. Remember that NFAs are endowed with the ability to guess perfectly when faced with the choice of the next state. To run the NFA using an ordinary computer, we must find a way to simulate this guessing. And the next part will be exactly about the guessing. We have this regular expression, so we have alternation, one pattern and another pattern, we have input string, and our alternation starts from the beginning. And machine needs to guess which path to go. And in our case, it will go the first path first. So this is our example. What is going on? We are on the initial state, we receive A, we validate, okay, A matches, we go to the next one, we have B, it validates B matches, and we go to the next step. Our input is B, but our this part of regular expression expects A. And what happens in this case? Yeah, it fails actually. And this technique in the regular expression matching, call it backtrack, because we just will go to the beginning of our input and we will try to match go to another path. So we again compare A, then B, then B. This time, second B matches our input and we at the final stage. So we matched our regular expression. This is good. So the problem of this technique, we tried only two different passes in the example, but in the worst case, it could be exponential, many possible executions, and brute force will not work. And talking about languages as a Perl, Ruby, Python, I don't know how it's right now, but in the past, it was implemented with this backtracking mechanism. And if you look at this chart, you will see that with increasing amount of characters in your regular expressions, the time consumed by execution jumps drastically to absolutely impressive numbers of seconds. So to use more efficient but more complicated way to simulate this perfect guessing, we will guess both options simultaneously. So why not? In this approach, the simulation allows the machine to be in multiple states. To process each letter, it advances all the states along all the arrows that matches the letter. So how it looks like, exactly as the previous example, but we go two passes simultaneously. We pass it A, we pass it first B, we go to the next B, it's here, and the first pass fails because it doesn't match our input, but the second one still continue and we can reach our final state. So this is dramatic improvement over the exponential time required by the backtracking approach. The efficiency comes from the tracking the set of reachable states, but not the path which we use it to reach them. With backtracking, we keep the path to go back. With this one, we just keep the states we are right now. So, and let's go to some implementation. As I promised, it will be some code in Golang, but you can convert it to any language because I was using C++ as a reference, to be honest. So to compile our regular expression, we will use some struct to describe our state because it's state machine. So we have character, we have output 1, output 2. This will I explain a bit more. And to describe our states, we will again use A to Z characters and we will represent them as an integer. And also we have some specific character numbers we are using for some, the alternation and matching state. So this is alternation. We will use this number as a alternation. So our program will understand that it should go a different path. And we have this matching character also embedded. So if we read the state, then it means we finally found the path which is correct one. So first of all, we need to compile NFA. And how we will do this, we will go from the end of our regular expression. Why? Because these meta characters, they always go the second one up after the normal character. So in this case, if we go from the back to the beginning, we can, find these meta characters first and then react better on the what is before it. This is and this is how we compile our NFA. So this is a presentation of one character. So we just create a state, we put the character there, and we have output to the next state. Actually, it is the same linked list I was creating in my implementation. And for concatenation, it's absolutely the same, but we concatenate two different states. For alternation, I will go more details here. Alternation is better here. So we create a state to match this character, and we also create a split state with this special number here. And output of this split will be this just created state and the state we had before, like just to link it to the next states in our regular expression, and so on and so forth. So we have loops, we just create and loop these states to each other, and so on and so forth. So we created our NFA, and right now, as I said, we need to track states we are right now. And for this, we have a list. On the list, we defined some, this is a helper function, but more interested this one, because every time when we taking our states and when we matching some character, we want to create a new list with new states, which will be after we finish the current list. So what we do, we usually have two lists, the current one and the next one. The current one we're going through, and if we match the character, we add to the next one new states to be matched in the next state. And this is actual function to match our regex to run our NFA. So first of all, what we do, we create an NFA, as I said. We add some initial variables to the list. We create two lists, as I already mentioned. And what we do next, we just iterate through the input string. And this step function will be explained next. But what we do, we pass the current states, we pass the character, we pass the next state. And at the end, we swap list, because when we pass the first step, we want to use the output for the previous one as the input for the next one. And the last, what we do, we just go through the output of the last run of our NFA, and do we have any state which is match state? If yes, it's true. If not, false. And the last, as I said, it's a step. So every step, what we do, we clean our next list, and then we just check if this character we received as an input, is this matches any state we have in the current list. And if it's matches, we add the next state from this current one to the next one. And that's all. And actually, implementation of this takes less than 100 lines of code. This is amazing. And back 6 years ago, I implemented this, I ran it. And what is more impressive, knowing this technique, you can solve any lead code question which is about regular expressions. So you learning how to solve like 5 to 10% of lead code challenges in one run. And yeah, one more thing. This technique I just described it in this talk is only one of many. There are, I already mentioned backtracking, there is virtual machines. This one I just like because it's very simple to describe, and this is really something refers to my past in the university. And also, you need to take into account when you have a real production code of some language, for example, Go, and it doesn't use some specific implementation of this. It's always uses different implementation based on the input. So it could be very different algorithm behind it when input small or input big or whatever. Also, during creating this presentation, I found very useful tooling. There is a link, unfortunately, this very small screenshot, but these represent the email validation matching from the beginning of the presentation. It doesn't look this scary if you do an NFA, right? And that's all. I'm ready to answer any of your questions.
All right. Interesting. So I thought it would be much more of a talk about showing different regexes, but seeing how they work under the hood and why they're actually being slow is an interesting idea. So have you implemented any of that in production, and did you see any opportunity to actually tweak these kind of things and make them faster? Because regex got a bad reputation lately about having like performance issues, security issues, all kind of things. So how do you use them in production? How do you use this knowledge to actually make sure you don't do the wrong thing?
I believe the guys who develop languages, I believe in the Go team. I mean, I already mentioned I'm a backend engineer. I believe they implementing everything with the best practices. So I don't implement my regular expression machine matching. I know how it works. I can do this for to think of lead coding, but I would really, as I mentioned, it's never one algorithm to be implemented. It's multiple algorithms, depends on the input. So even if you open the source code of Golang, you will find out that it has different kind of branches. The same for example, for searching in arrays. It's different. As far as I remember, up to 16 elements in the array, it uses one algorithm. More than 16, it uses different algorithm. So
Okay.
I would better lie to the guys.
That's an interesting one. I didn't know that. I mean, it would be also interesting to see how other languages do it, because the other day we had a comparison about like the efficiency of languages in terms of like energy consumption. And it basically said that Python is absolutely atrocious compared to C++, which is not surprising. But at the same time, it's just interesting to see what kind of micro optimizations inside the engine are like that. So with Go, I didn't know that happens. It would be interesting to compare that to others, and if other regular expression engines do the same thing. As far as I understand, JavaScript uses the Java one, the original one, or used to. So it might be that there is good opportunities to optimize these things as well and do like some pre-caching and these kind of things. The standard of regex in JavaScript especially has been extended quite heavily lately. You have like named groups and callbacks and these kind of things. So have you looked into any of those, or is it mostly the like how the things work under the hood?
Yeah, I didn't compare implementation in different languages. I found the tool. I see it's amazing. And I said, like, if you're just doing this for lead code perspective, I mean, it solves everything in one run. You just create one like snippet of code, as I said, 100 lines, and it works on any code challenge, which is like regular expression matching. It's so like mind-blowing. It's so powerful.
There's a question in the channel. When you're following many paths, there's a lot of opportunity for parallelization and spread calculation on different cores, or even use SIMD. Do you know whether current engines like PCRE2 use OpenS?
Oh, I don't know this abbreviation, to be honest.
Okay, so you obviously don't. Yeah, but it's
Oh,
true.
I
Like
don't know. Sorry.
the different cores bit is an interesting bit, because I mean that doesn't apply to any of the JavaScript implementation, but in Go it would implement, and in Rust it would work as well. So do you see do you see any performance issues there that people should optimize their setups to make it better that way? Or is it more like how the code's written and the engine should do it automatically?
Yeah, I believe this is how it should be done automatically.
Okay, OpenS is not a thing. OpenS is just a short for optimizations. So
Yeah.
basically, do you know whether current engines like PCRE use optimizations like that?
PC. No, I don't know. I don't know.
Okay, in terms of tooling and in terms of learning about engines, I mean, there's a lot of interesting stuff that I've seen lately. I mean, we have for the newsletter, we actually we have an archive of all the links as well. So if you actually take a look at that one here, you can always go to. I'm not resizing the right screen here. Hang on. So if you go to the WeAreDevelopers.com links, then you can actually find like there's all kind of regex stuff in there. There's a template tag that extends it. There's key proposals. There's more regex escaping in TC39 in JavaScript as well. And in Python, there's a weird error in there as well. So, but what I really like is Regisper, which actually allows you to do like A, B, or A to Z, and then you can actually do a display, and it actually shows you the kind of strings that you showed as well. So you can actually do any functionality that you want to have, and it displays it as a fraction here, as a display here. So that's quite interesting to see if you want to explain, if you want to understand regexes how they work under the hood as well. And it's basically just if you go devrel via developers.com/links, that's where we have all the links from the newspaper, from the archive as well, or you can go to the link archive here and see it from there. So there's a lot of tools that help you with that. What was interesting to see for me was that a lot of people use ChatGPT to generate regular expressions, and they're highly unoptimized. Do you see any other way how we can get people into that matter more? I mean, you said it like you can fix any lead code challenge with it, so that's an interesting hack. But at the same time, I think in production, there's lots of benefits to regular expressions that people are not using yet. So do you think there's an educational improvement there? Is it just too weird to understand? Why do people not go for regex? Is it a bad reputation in performance? What do you think?
I don't think, I don't have any kind of knowledge about bad reputation of regex. I'm using it a lot. Every one of us using. Maybe people even don't know what's under the hood of their functions. Actually, this happens a lot. Before I became a Go engineer, I was a Ruby engineer for 15 years. And what I didn't find in Go, a lot of sugar functions we have in Ruby, which helps a lot to write. But then when I switched to Golang, I understood why some things in Ruby slow because of implementations. If you go to implementation, you understand it's something very simple, very dumb, and you can do this more sophisticated and it will be much faster. And people just don't understand that what is under the hood of the sugar functions they use every day. Most probably there are a lot of regex.
Yeah. Well, it's a bit like when people start parsing HTML and actually trying to find information from HTML documents and start using regular expressions. I think that's where madness lies. This is where you should use an HTML parser and actually make sure that the language is actually escaped properly. So the parsing of content is a skill that is actually needed all the time, but it's something that nobody teaches you. But I think regex and HTML is a very bad plan or mixture. Did you ever see a format that actually where you would not use a parser but actually just go for regex?
Ooh, no, I always will use parser.
Yeah, because CSV is another one that actually feels like it should be simple, but then you got like all kind of commata in the content, and you have to worry about that one. And again, you have to worry about the size of it. I mean, the other day I went through our format, our data from the Congress, and that was like a 1.2 gig CSV file. And yeah, there's no way I can actually use a regular expression on that thing without streaming it through something and finding the lines that way. So it's interesting to see that you can, I use PHP and you can max out an M2 iMac with just one regular expression. So I was very impressed by that. But yeah, that kind of information is something that that feels always very powerful, but at the same time, there's also a lot of danger in that. There was also I think Cloudflare had a problem that they had a regex in a build file, and that was basically taking down the whole cluster because it was basically running out of memory because it was an endless loop inside the regular expression itself. How would you debug that kind of stuff? Do you have any tricks on that?
Oh, I have another presentation, amazing one about debugging. And stuff about regular expression looping. Absolutely have no idea because this always happens somewhere under the hood, but then you can see maybe some part of the code which starts your regular expression, starts some process with this, and you can find out this process, going faster and faster with memory. This may be possible, but to be honest, what I wouldn't be kind of blame first, the regular expression maybe. I would blame some another code I wrote myself because this regular expression is something very small. You never think about this can, cause this huge harm.
Yeah. I mean, there's always this look ahead problem as well, that basically you do like a plus star and basically don't realize just how much content it would actually do. So when you match bits, like always make sure you know the brackets that you want to match, because otherwise the rest of the document might get put into a variable and you don't know where it is. But I guess performance-wise, was also a question like, how do you do performance checking with regular expressions? I guess the answer is to take a look at your memory consumption and take at your CPU consumption and see which one is skyrocketing and when. And
do load testing.
yeah. So you have another direct. You said you had another presentation on that topic in general. Is that available somewhere? Have you given that already, or is it something that you also wrote 5 years ago and you still have on the back burner like this one?
No, this one is quite new. Year ago, I did a presentation and I presented on GopherCon. It was a lightning talk this June.
Okay.
I have it somewhere in the internet, so you can find it. It's
Okay.
fun. It's a lot of Gopher memes and a lot of findings.
Yeah, you had a lot of those in there. It's an interesting community that actually, if you give it a cutesy mascot, you can do a lot of cool stuff with that one.
Yes, exactly.
One thing I always wondered about as well is like, how could you prevent? How can people evaluate a regular expression that they use? When I talked about earlier, when ChatGPT or when Stack Overflow gives you a regular expression to do a task, what are danger signs that you see that you say like, don't use this in production because obviously there's something wrong with it? Like, what are the things that people should take a look at and say like, that seems fishy? Is there something that stands out to you in a regular expression that you should be worried about?
In a regular expression, maybe not, but I have seen a lot of my life, people just copy paste from Stack Overflow or right now from ChatGPT entire answers without understanding what exactly it does. I mean, I believe the teams who is working on languages, they are doing a really great job and they implementing some protection mechanism. Like, in databases, you escape your input values. So they escape it and validate it that nothing could harm your system. I mean, okay, Cloudflare show it us it's possible, but I hope so this evolve every day, this being improved every day, and I don't think, I mean, except you do remember on one of my slides, there is a regular expression for email matching. I mean, what you can do to validate if it's real regular expression.
There is the official one, which is like the two-screen like email matching thing that people had, and I mean it changes every 2 months when there's new domains out. Like it used to be like only 3 letters for a domain name, then it's 5, then it's up to like whatever. And now you got things like zip domains and all kind of weird stuff that are actually not that look like other files. So it's tricky to actually make these things happen. So it's really annoying because I would love to actually have I mean, I love that we have these register and these kind of things, but I would love to have like a more gamified thing. Like, I mean, when CSS got like Flexbox and Grid, there were like games that actually would allow you to learn the syntax that way. But I haven't seen anything like that when it came to regex. It's more in the style of your presentation where it goes directly back into engineering knowledge rather than just like play with it and see what you can do with it. Might be an interesting thing to try to build something like that maybe in another hack day or something. I think it's a great tool that gives you a lot of opportunity to shoot yourself in the foot. And we hope that engines actually do the optimizations that you talked about. But again, like if you can't see how it works, I'm always wondering if it works. So that's one thing that I learned in my career, that basically like hoping that something gets optimized under the hood is most likely not the case if nobody asked for it. So maybe that's a good call. Like basically everybody here in the community basically go to your favorite language and ask people, is there optimization under the hood? And if not, look at how Go is doing it and then do it the same way.
I'm not claiming Go does it perfectly, but I believe in the guys.
I mean, you talked about Ruby and going to Go and having like all kind of convenience methods, and I found the same with PHP. And then when I went to JavaScript, you got like UC first, UC words, like all these conversion things that basically PHP has built in, because whenever they had an idea, they just build a function and then randomly made the order of like haystack and needle differently, so that made it hard to read. but it was just interesting to see like how many times I've written JavaScript functions that were native PHP functions. And when it comes to the Code 100 challenges, I sometimes had a challenge that I thought was clever in JavaScript, and then I looked at it and I'm like, oh God, PHP has a function for that, or Ruby has a function for that. So these convenience methods are something that people get very much used to, but learning how they work under the hood is, I think, very important. And that's where your talk was very good in terms of like, here's why they actually become so exponentially slower the more you use them. So what's next for you? What you want to do? How do you want to take this knowledge now that you've given the talk finally? What's the next steps with it?
Oh, to be honest, this is not the first time I'm giving this talk. I gave it 6 years ago in Delivery Hero. It was already 2 times. So I don't know. Let's spread this video.
All right. Well, thanks very much for this. So this was Andri, and all about regular expressions and pattern matching under the hood. And we're moving on to the next section of this talk. So thanks very much. We're going to edit the video. It's going to come out next week.
Bye.
And I see you then. Cool. So this was the time for my second monitor to die. So I don't know what's going on there, but okay. Now we're going to have a more interactive bit again as part of our session here. And what we're going to talk about is like it's again a bit that we have on our website and we also have in the newsletter. So if you actually take a look at let me quickly open that one. If you are not subscribed to our newsletter yet, what are you doing with your life, first of all? And second of all, we have these quick trick sections in there. So in this case, it has, for example, here, again, I'm using the wrong screen. We got this quick trick here where, for example, you have flat map and it makes it simple to get nested properties from an array of objects and so on and so forth. And if you go through that one, you actually have a quick trick section on our website where I explain all these things. So basically, we have a data set of the videos Word Congress, and I needed to find like things like tags in here and flat map, which I just discovered actually made it super easy for doing these kind of things. You have all these kind of quick tricks here as well. So in the past, we talked, for example, how to edit any website by using content editable. It's always a great idea to do that, because if you just do it, take this one here and copy and paste it into the URL, you actually can start editing. Oops, that's interesting. I didn't know it did that. But okay. Did that change? Oh, it takes out the JavaScript. Look at that. Might be a new security feature that if you copy that in, it actually doesn't do it. But if you do that now, then now the site becomes editable. So you can actually start editing the page, get rid of the logos, get rid of all the things that you don't want to have. And the really cool thing about it is also you find typos with it, because it puts like the curly underlines on it. And for example, jobs is spelled with 2B and these kind of things. And it's a very good way to actually mess with websites before you actually start printing them, for example. We also had a thing in there about dark and light mode, that is not an inbuilt CSS function. And the flat map thing that I just talked about, which might be interesting for a challenge later on as well. And a copy button, how you can make that with a few lines of JavaScript, you can actually make a button that allows you to copy content for people there. So you can say like, this is copied. You can send another payload in there. You can have bells and whistles and a delay and all kind of stuff in there, and you paste the results in here. Now, this is the things that are already on there. And one thing we now going to show you is a video that my colleague Dan has done. So it's going to be a massive deep dive into shortcuts for Visual Studio Code. So without further ado, let's take a look at that video together, and then we can go back to the tips and tricks after that.
Hello, my name's Dan. I'm one of the developer advocates here at WeAreDevelopers, and in this video I'm going to show you some of my favourite and some of the most useful shortcuts for when you're using Visual Studio Code. Now, just before we begin, I will be referencing the Mac shortcuts throughout this video, but I'll show the Windows ones on screen as well. So to get started, Command-Shift and P is going to open up the command palette, and this is going to show us everything we can do in VS Code or some of our recent commands. Now, you probably already know that Command and F will do a search within the file that you currently have open, But if you use Shift Command and F, this will do a search across all of the files that are currently open in the editor or in the repo that you're currently looking at. Now, this next one is not one that I actually use very often, but I have spoken to other developers who will swear by it. So if you want to have multiple cursors, simply use Command, Alt, and up or down on the keyboard. And you'll see here that it creates a new cursor on the line below. And then when you type, it will type onto all of those lines at once. You can delete a line of code without selecting it. Just click anywhere on the line and press Command, Shift, and K. To duplicate your current line or to copy it down, all you need to do is press Shift, Alt, and the up or down arrows on your keyboard. Now, of course, indentation is handled most of the time automatically, but you can increase or decrease the indentation simply by pressing Command and either of the square brackets. It's a great alternative to pressing Tab, as you can be anywhere in the line when you press this shortcut. Next, let's take a look at a few tips that will help you when you're specifically working with Markdown, which is great for readmes or documentation. Now, the chances are you're going to have some Markdown and you want to preview it like this. So to open that up, simply press Command, Shift, and V, or you can do side-by-side mode by pressing Command and K followed by V. The great thing about this is if you make any edits, you can see them in real time. It's really easy to navigate down to one of the headers in your file. Just press Command, Shift, and O and click it in the dropdown. Format your Markdown or refactor your code easily with the Surround With menu. Simply press Command, angled brackets, and the suggestions will pop up. Next, let's take a look at a few ways that you can navigate around your code base. So using Command P and typing in the name in the input field, you can go to a specific file. Now, if I'd like to go to a specific line, even if it's nested like this one, I can just use Control and G, so that's Control, not Command, type in the line number and press Enter. If you're like me and you probably spend more time than you'd like to in the Problems tab, you can toggle it on and off with Command, Shift, and M. You can go to the nearest outer bracket using Command, Shift, and backslash. Or using Command, Shift, Alt, and the arrows on your keyboard, you can expand or shrink your current selection. To fold or unfold all of the subregions to your current selection, just press Command, Alt, and square brackets. To unfold all of the regions in the current file, just press Command and K followed by Command and J. And to fold all of the regions back up again, press Command and K followed by Command and 0. So let's just unfold those again using Command K and then Command J. Now we'll use Command and the down arrow on the keyboard to go to the end of the file. In this final section of the video, we're going to take a look at a few tips for keeping your code clean. So to begin with, if you've got some poorly formatted code like this here, just pressing Option, Shift, and F will format it, though of course you could add auto formatting or formatting on save in your preferences. This next one is so simple it's almost easy to overlook. Alt and Z is going to toggle word wrapping on and off, so this is really useful if you've got very, very long lines of code and they're going off the screen to make sure that you can read it all. We're all guilty of importing packages and then realizing we don't need them anymore, so make sure you remove those unused imports using Option, Shift, and O. You can add comments throughout your code. Now you can do this either by selecting an individual line and pressing Command and /. Now, of course, you could do this by selecting multiple lines and using the same shortcut, but in this instance, I would recommend using the block comment, which would be Shift, Alt, and A. Finally, if you'd like to find repeat instances of a specific term in your current file, simply select it and press Command D multiple times. This will then select each subsequent instance of that term. If you add one too many, just press Command U and it will remove the last instance from your selection. So I hope you found this video useful. You can keep up with all of our content by checking out WeAreDevelopers.com. You can see more information on our live days at WeAreDevelopers.com/live or follow us on socials.
Well, that was a lot. So what we did as well, and by the magic of GitHub Pages, if you reload that one now, you now have the useful VS Code keyboard shortcuts as a table here as well. You can also do that, of course, inside Visual Studio Code. There's lots of functionality that's in there as well. Command Shift L, for example, is the Command D for all of them if you have them in the whole document. The thing is, I've been using keyboard shortcuts for my whole life because my first computers were really, really slow and the mouse was actually not fun to use. So I got really into keyboard shortcuts, and it's really scary when people are next to you and ask you what it was and you don't even know anymore because it became such muscle memory that you're just working that way and you don't understand it any longer what you're doing. So it's fun to actually get this kind of videos and this kind of list here as well. So this list is available. I will put the video on top as well, and we're going to release that on our social platforms in the next few hours or days, so that then will be available for you as well to do that introduction. Also, follow the VS Code team itself on Visual Studio on YouTube, because I've been doing some videos for them in the past. They always have some really, really cool little details in there that you might not know about. And it's incredible how much more effective you actually become if you know the right shortcuts rather than just having to use your mouse and go through the menus and these kind of things. The biggest trick is actually Command-Shift-P, which always gets you the command palette. So that one gives you all the functionality that you actually have. And the interesting bit is that is not only in Visual Studio Code, but if you're in your browser as well and you do Command-Shift-I, for example, to open the developer tools here, Command-Shift-P in the developer tools work as well. So you can run commands, but you can also do all kind of like looking up what the functionality is. So the developer tools in Chromium browsers are like, I think 72 different apps in one big app. So you don't even know what all these things are anymore. So oftentimes you find functionality that you don't know. For example, print. You can emulate the print media type, and you can just do that with Command-Shift-P and go in for that as well. It's interesting because a lot of websites do that as well. If you go, for example, for GitHub, and on any GitHub page, which you actually, I'm on a private tab here, they have a Command K menu as well. So you can actually do all kind of GitHub commands in GitHub itself by using that keyboard shortcut as well. So think about trying to find that command palette, because that would gives you a time advantage of like not having to find the different bits in the functionality itself. So hopefully these links will help you. We will release more of them over the next few weeks and months, and I probably will get Dan to actually shorten a bit and not show all of them at the same time. But we had them as shorts on Twitter and on Facebook in the past as well, so they will be coming back again. Which is what we have for the quick tips this week. If you have any quick tip that you want us to show, please also contact us, Chris at WeAreDevelopers.com, or comment on LinkedIn or wherever you want to see me. And then we can publish yours and maybe get you some goodies if you actually send something in that's interesting. Talking about sending something in that's interesting, I want to now actually introduce Daniel to come up on stage next. Daniel is our next speaker, and I'm very excited that he's here. How are you doing?
Thank you very much, Chris. I'm doing great. Great segue, by the way.
And you got a beautiful, beautiful place. I actually been there as well, I think.
Oh, yeah? Yeah. I feel like this is a shared space that everyone who does meetings on the internet gets to use all the time.
It's a bit like me as well. I mean, this is not my flat, of course. The flat behind me, there's like new life forms coming out every 2 weeks. So it's very small and it's very warm. And this is a shame that I don't live in a place like that. But it's all good.
Oh, yeah, it is a shame. I was about to ask you for tips on keeping plants, because those look like some really healthy plants.
Oh, you can talk to my partner for that. She's amazing in that. We've got this balcony out there, and there's monkeys and all kind of stuff in there. It's huge, and it's like we didn't buy any herbs for like a year. We always got that from our balcony, so that's pretty cool.
I can't even keep my mint alive. Yeah, I absolutely have to do that. Thanks.
I guess it's talking to them the right way, but I don't know. We cannot prove it, but it might be the thing to do. So your talk confused me. So it's actually you want to train our front end to see. What do you mean by that?
Well, without saying too much and spoiling the talk, the idea is giving your front ends the ability to understand visual information, basically. And a bit of a spoiler, it uses machine learning algorithms. I think when we look at websites and the way we interact with them and the way we interact with lots of AI is through text, right? And I just want to sort of dispel that limit that we've set for ourselves and show people that you could do way more with your websites than just look at text, read text, and you can have your websites see and interact with images or video or maybe even audio.
Yeah, I mean, when I worked on Firefox OS, that was the big breakthrough when we actually had to make everything like microphones, cameras, and make everything much more standardized to get the way into it. Before that, we had Flash to do that and Silverlight, and then the HTML5 platform needed to make it easier as well to actually get a multimedia experience, input and output.
Yes.
So it's great that we have these things now, and it's interesting to see a lot of the stuff that we did back then, in the end, the first ones to use it were people who are actually the horrible people of the internet, like turning on your microphone without realizing it. So we had to make sure that doesn't work out, and like ads that would actually film things. And it was just a very interesting that when you go past the normal things that we do as developers, the first one to embrace them are the bad actors of the web, rather than the people that want to do creative stuff with it. So I'm now really psyched about this. This is really cool. So what do you normally do? Like, what does WeAviate do? Like, do you fly planes, or what is that?
I get that a lot. But I've got, do you do, what's this word? Textures or garments or a lot of things like, no, we don't do any of that. Actually, WeAviate is a vector database. So it specializes in helping developers build AI native applications. That's what we do. Also, it's pronounced WeAviate.
Okay.
Yeah. So
And-
that is what the company does. You did ask what I do, so
what do you do?
I'll talk a little bit about that. So I help the company sort of target JavaScript developers with their SDK. One thing you know about vector embeddings or machine learning is it sort of has over representation of Python developers, which is understandable. And so my job is to craft the developer experience of the JavaScript and TypeScript SDKs. That's from the product level and the actual SDKs you use to the educational resources that you look at or the documentation that you read. So that's sort of my everyday job, sort of cycling between these multiple hats.
Okay, that's cool. I mean, it always fascinates me as well when it comes to, like, back in the days, you were looking for something on the web and you got like a website with like 3 bullet points, and now you get a 7-minute YouTube video where people ask you to like and subscribe, and then basically do the kind of like, it seems like we, instead of merging the two knowledge sources, we just tried to replace one with another because it was easier to monetize. So it's kind of interesting to see what we could do to make that better.
Oh, absolutely. I agree. And there's definitely an application, not to like plug my talk too much, but that's there's always that separation. It's either text or it's video, like I think part of this talk is also saying you can have both and benefit from each.
Excellent. Well, I mean, we're 1 minute over, so I don't want to talk too much into your talk because I'm super excited about it. So I give you half an hour to woo us with making things see.
Oh wow, you have the actual timer. Very cool. Okay, thank you very much, Chris. And thank you for everyone who's tuned in to watch this. Like Chris said, my talk is Vision for Websites, Training Your Front Ends to See. I'm Daniel Piri, and you can find me anywhere online as Malgambiz. So I'll make this joke a couple times. Very late into like preparing these slides, I was like, vision, that sounds like something familiar. So just so that I can sort of amuse myself, I've sprinkled a lot of these pictures in a bunch of the slides. So I hope you enjoyed as much as I enjoyed. I already mentioned I do developer experience, also happen to be a writer, developer, artist, and plant dad. That's me asking Chris about the secret behind plants in his background. Right, so straight into our talk. What is vision? I also happen to really like definitions. I found this one on Google. Didn't really look too far, but it sort of captured everything I wanted to in this definition for vision. Vision is the faculty or state of being able to see. Very simple, very straightforward. And one word I want to highlight here is see. Because if you're human like me, when you think about seeing, you mostly associate the act of seeing with, our eyes. But when I define see in this context of this talk, I like the definition that says to see is to discern or deduce after reflection from information or to understand. And this is what we're going to train our front ends to do today. We're going to train them to deduce, much like Sherlock Holmes would. And hopefully we have some fun doing that. So that I can keep your attention, I'll give you a demo of an application that I built. It's sort of meant to mimic sort of an experience that you'd have on your phone, because it was a bit too cumbersome to actually have my phone record and structure this demo in a way that would actually be useful to you. I made this application, which is called Shop, modern retail, buy almost anything, almost literally anything. And so we have a couple images here, usual experience. You could buy like a car, no price. We could just buy that, or we could buy like corn. And usually when we search for things, we could search like iPod. I see there's an iPod there. I want to see if there's any somewhat audio-like interfaces. Okay, yeah, this was bound to happen. I just need to add my environment variable. So give me 1 minute. I'm using, spoiler, I'm going to get into it a bit later. I'm using Google's multi-model machine learning model, and that needs me to have an environment variable that I use. And because I don't want you all to see my environment variable, I'll just take this away so we can do this safely and no one sees that. And I'll paste it.
You can also remove your screen until you're done, and I just did that. So do your worst.
Thank you very much for that security check. I think it should be good now.
Okay.
I'll just restart my server, and then
I just don't want to edit the video again, so I'm doing work for myself here right now.
Aha. Thank you.
Cool.
Right.
So we're back.
We're back. We're so back. So see, I could like add that car. Let's say I want to buy other cars. And so I'll search specifically like white car, or maybe like a Golf. A Golf. It's a VW Golf. And so you probably don't understand it now, but we have something that looks like a Golf. And what we're doing now is searching over these images, not for what their metadata contains, but for how a machine learning model understands them to be. I could also search like sports cars. Maybe I want to buy sports cars. There's no category here that defines what's what. It sort of just looks at what's available and then sends that back to me. And then this is the vision aspect, actually. I will look for a car or grapes. I think I want some fruit. It's around lunchtime in Paris right now. And so there's an understanding that I just uploaded a picture of grapes, and I want something like that. And you could see I have 5 items in my bag. Maybe some beer. Let's see what we get. Okay, nice nuggets and chips and a person drinking a beer. Maybe that's an ad for beer. Let's add that beer. So basically what I demoed was this ability for you to have this interaction in any sort of application, be it on your website. This is an application that I built with Nuxt.js, Google's Palm Vertex model, and WeAreDevelopers. And we can search through anything we want with text and with images, and we get back relevant results to what we searched for. And this is what I'll be teaching us to build today. A modern retail store that sort of understands the context of our applications. So what you just saw was me demonstrating multimodality. Multimodality is what we use to sort of give our applications, our websites, vision in this way that I described, where they can deduce information, understand it, reflect, and then act on it depending on whatever request that we have. In our demo, our request was we wanted to buy something, and we looked in this shop store, and when we found what we wanted, we added it to our cart. So multimodality, we'll get through it again. It sort of enables search queries with multiple media types or multiple modalities, where modality is a description of that type of media. This could be audio, this could be text, this could be video, this could be sort of time series data, and the list goes on. Different machine learning models have different modalities that they support. And the important thing about multimodal AI is it helps us capture more context and improve the experience of an interaction, as we just saw. In a normal sort of non-multimodal world, which I feel like we don't exist, but we're forced to be existing in, we would search something with keywords and we'd struggle to find exactly what we want. We'd have to sort of figure out what something is. We can't really like take a picture of something quite easily or integrate that sort of functionality into our app. This was something that was kept for these bigger tech companies. And the beautiful thing about multimodal AI and open source models are they are democratizing access to things like this. And they're helping us achieve this idea of a multimodal world. Because I truly believe that we are multimodal people. So let's get on with it. Why multimodal? I think I already sort of alluded to the fact that it gives us a richer, more enhanced experience as we're dealing and interacting with interfaces. And the majority of us already interact with computers, interact with the internet, mostly through the web. And I think a lot of people have tried a lot of things. I don't know if you're familiar with who this person is. I'll usually say hands up, but I can't really see you all. But this is a tech YouTuber who reviews tech products called Marques Brownlee. And a couple of months ago, he reviewed two very interesting products. And there was this whole internet meme about him killing companies by reviewing their products. And in actuality, what these companies were trying to do is recreate this multimodal experience that we have and integrate this with AI. Great attempts, execution, questionable. I'll let you watch Marquez's reviews. But my question here, and sort of my goal in this talk, is to sort of bring this idea of multimodality and have people use their creativity and implement that across whatever sort of applications they would like to build on the web. And I'll show you how. So yeah, why multimodal? The whole idea is giving more contexts, making interactions more natural, and just taking in more modalities. I think Chris shared an incredible example of content creation for developers, how we had this big jump from everyone was sort of doing text and having blog posts, so now everyone is doing like a YouTube video and asking people to like and subscribe. Where in a very multimodal world, you have the best of both worlds, because your AI can understand that when someone searches, how do I access the camera API in my browser, they don't just give you a YouTube video, 12-minute long YouTube video with the answer halfway through. They give you the option to pick whether you want a blog post or an MDN resource or a video. And so this is the idea of a multimodal world that that I would like to live in, and I feel like we should. Excuse me. Right, so multimodal AI, we sort of understand what multimodality is. We've seen this very quick demo of what a multimodal experience looks like, but I would like to sort of dissect multimodality into two specific things. Because when we think about machine learning models, a lot of us think ChatGPT, Claude, and those are generative models. They generate data based off some sort of user input. Embedding models, lesser known, are what we'll focus on today, the lesser known ones. So just to sort of give you an idea of embedding models, these are models that encapsulate information and then plot this into a multidimensional space. So whenever we want to process data, run it through pipelines, or do some sort of retrieval, augmented generation, with different other modalities, we'd use embedding models because they give us that ability to understand different sorts of data. And I'll get into exactly how they do this a bit later. And the idea of, and just to sort of like bring this point home, embedding models encapsulating information in numbers isn't something new that we face as developers. This is web dev days, and I think most of us at some point have assigned color to something on a website, right? So the idea of encapsulating number, like information in numbers, isn't new to us. We have the RGB system that helps us assign a number from 0 to 255, depending on how much red, green, or blue that color has, where red is 255, 0, 0, and emerald is 80, 200, 120. And so each number sort of helps us understand the level of a specific character or a specific quality. And this is what multi-model or embedding models rather do with the embeddings that they produce. So if you want sort of like a demo app, sort of understand how colors are plotted in a multi-dimensional space, where the dimensions here are red, green, blue. I'll share my slides after this and you can have a look. And so just like quick pause from embedding models, which I'll get deeper into. I think something most people are familiar with, these generative models, which produce new information based off some sort of user input. So a lot of people want to create images for blog posts. I think a lot of people also are familiar with this very famous demo from OpenAI. They released a video model called Sora, where everything here, there's actually audio, but this is a GIF. But if you've seen this demo, the audio, the script, the actual video frames that you can see were all created by an AI, or rather a generative model, because that's what generative models do. Okay, right. Today's talk, like we mentioned, is about vision. How are we letting our computers deduce information, understand it, process it, so we can actually do things with it? That is what we're using embedding models for, because they are the ones that can encapsulate that information, and then we can use that information to do other tasks. So we'll zero down and focus on embedding models. Now, to sort of understand embedding models, I will explain vector search, because this is sort of like the cherry on top when it comes to one, embedding models, but also giving our websites vision. So I've talked about these machine learning models. Embedding models, they encapsulate information and store it in an array of numbers that are called embeddings. I have mentioned embeddings a couple times at this point, but I haven't really shown you what embeddings look like, except when I showed you the RGB system. So quite similar to the RGB system, where instead of having 3 dimensions, red, green, blue, to describe a color, we have from hundreds to thousands of dimensions to describe data that's input. So machine learning models are trained specifically to understand the world around us and create these abstractions represented by numbers, which we call vector embeddings. And so within multi-model embedding models, we can take in text, we can take in audio, we can take in video, we can take in so many other things and create these embeddings. And the really interesting thing about this is these things get added to a unified space, which I will get to a little later. And so to sort of understand how we actually do this vector search, because vector search is what powers this deduction, this ability to understand and get that meaning. We could have some sort of data. We'll work with text data because I think it's a medium a lot of people are familiar with. And so we have something like fly with expensive airlines. And so we take that through our machine learning model. This could also be an image. This could be a video. But the idea is once we process that through our machine learning model, we create these vector embeddings that encapsulate what this data represents. And we do the same thing for all our other data. In this case, we have airplane wings. It's like a quick blurb on why and how airplanes fly. And once we put that through our machine learning model, we get our vector embeddings. And then when we want to then put those into our vector space, our multi-dimensional space, like I shared. The RGB system has 3 dimensions, red, green, and blue. For illustrative purposes, I'm using 3 dimensions, but in actuality, multimodal, also rather vector embeddings can go from 300 to 1,000 to hundreds of thousands of dimensions. But the idea here is once you put these items in the vector space, by design, these vector spaces sort of act as coordinates. These vector embeddings act as coordinates for this object in a vector space. And as you can see, each item here tends to be close to items that are similar to each other. And so we have a cat and an image of a cat. So ideally, when we search something, we'd get as a response both the text cat and the image of a cat, because vector search works by distance. And how that works is we get whatever query we have. So in this case, if we ask, why do airplanes fly? We pass that through our machine learning model, and then we get our vector embeddings. When we put those vector embeddings in our vector space, right, this happens to be the position of my query, why do airplanes fly? We look around it using distance algorithms and then send back the most relevant, or rather the closest, because based off this understanding of how vector embeddings work and us plotting these and them acting as coordinates, the ones closest to our query would be the most relevant in this space that we have, given the data that we've input. So when we do why do airplanes fly as our query, the most relevant happens to be our NASA article, which sort of explains the mechanics of the shape of the wings and how moving through air gives planes lift. And so this is how multimodal, or rather vector embeddings and vector search works. Now, the interesting thing, like I mentioned, is you have these multimodal embedding models that take in all sorts of data. So they can take in audio, they can take in video, they can take in text, they can take in time series data, and they put all of that information in this vector space. And what we can do now is when we put in a query, any sort of question, just to check what's the most relevant response or the most relevant object close to this item, this query can come in the shape of an image or a video or text or audio. And that way we have this very multimodal natural interaction. And so we already looked at this slide where we took things, we took this text query, we put this through our machine learning model, and we got our vector embeddings. And sort of to drive this point home, we could do the same with all sorts of data types. And this is sort of how these multimodal machine learning algorithms work. We get this text, we get this image, we get this audio, we get this video. We pass them through different encoders that are specific to their data type, and then we get the corresponding vector embeddings. And then we plot them into our multimodal space, and we can run queries, which means we can do an any-to-any search. Excuse me. We can get lions roam the savannah, and that could be our query. And the sort of response that we'd get, it depends on what's in our space. We could also have a picture of a lion as our input, or an audio of a lion roaring, or a video of a lion roaming the savannah. And our response can come in the form of either information like king of the savannas, being a lion, image of a lion, other audio of lions roaring, or another video, because there's this understanding that we've put in something related to lions. And so if this is the data, lion-related data that is in our vector space or our vector database, that's the data we get back. And this is how multimodal embeddings help us achieve this idea of vision, right? So I've talked a lot about multimodal embeddings and theory and all of that. I think now it's time to sort of dive into some code so we can actually understand what's going on. Right, so another demo. We'll go into our Nuxt application. It's like I mentioned, we have a Nuxt application here that we're running. I'll just walk you through its architecture so we can understand how how this works and how distance plays a part. So if you're unfamiliar with Nuxt, it's a framework built on top of Vue.js. That's why you see this app.vue. And so in app.vue, we have a component called iStore, which is our component that has our shop. And so we'll open that, and I'll collapse this. There's a lot of HTML, but essentially this mirrors our application. I'll just do this. This mirrors our application, and I will reload. This mirrors our application that we see. So shop, modern retail, buy almost literally anything. And when we have a counter here, just to store how many, just to keep track of how many things are in our bag. And that's exactly what you see, a bunch of templating. We have a button here that represents text search that we run. Because like I mentioned, even though we have all this image data in our database, we also have a bunch of, we can also run text search over these images. And then we have our second function here, which is convert image, which gets a local image, converts it to base64, and then sends that into our database to then run that search. And then we have some like the script section, which is where you put your JavaScript in Vue.js. We have a couple variables initialized. And most importantly, we have this useFetch method, which makes a fetch request to an API route. So essentially, we have an API route that makes these searches for us. And we'll explore this search API route before we actually get into how everything else works. So again, back into here, we'll get server, we'll open our search.ts. And this is essentially how we run our search. This is built with the WeAreDevelopers TypeScript client. And so I'll just walk you through what all of these things do. And so essentially when we press this button, search, we call our search function. This is blank at the moment. So I will search for cars. Let's see what we get back. So we get back a bunch of cars. And as we keep scrolling, we get cars, we get more cars. And I see here we have a couple old cars, just to sort of illustrate that there's this sort of understanding of the data. So if we say old cars, or I think the right word is vintage cars, then we can see that the type of car we get is more old, because the model understands that this is what we're trying to get. It has an idea of what this image represents, and that's what it sends back to us. And we could also describe these cars a bit more. I think the beauty of these multi-model models is we have that option. So what could we say? We already said old cars. We could describe the color of the cars. We could say white cars, white cars. And so now you can see we have white cars, and we can add those to our bag. And interestingly, because of the way vector search works, it sends you the most relevant items with respect to distance. And so as the distance grows, you at some point start to see cars that aren't necessarily relevant. And we can cut that off. And I'll sort of explain that. But now that we sort of just to refresh your memory, to look at what this search functionality is, essentially in our database, we have a bunch of images with no metadata. And then we're using this text search to search through these images. Right, so back here, what powers this again is WeAre, and we're using the WeAre TypeScript client. We import Zod for some query validation. We're using an event handler to handle requests from your front-end application. And then here we initialize a connection to WeAre Cloud, which is what we're using. You also have an option to use WeAre locally through the open source Docker version. We pass in our API key. And most importantly, I mentioned the machine learning model behind this is something called Vertex Multimodal AI, which is a model from Google. You have the ability to use a bunch of other different multimodal models, like Pixel or ImageBind from Meta, or Clip, which is an open source general use multimodal embedding model. And what we're doing here is we have a function called vector search. And once we validate that our query sort of matches the schema, we then pass the search term that we get from our front end and then run this vector search. And so this is the actual code that represents the theory that I was explaining and I was going through before, where we choose a collection, which you could think of as a table in a database in WeAreDevelopers, and then we use that collection to make a near text query, which is our version of a vector search that gets a text, creates vector embeddings for this text, and then passes that into our vector space, and then sends the most relevant items back. We have a limit of 20. We also have the ability to limit items automatically. And so we have something called auto limit. You could see TypeScript there helping me out. And so essentially what auto limit does is it groups responses with cutoffs. So when you have a bunch of responses that are similar to each other, and I think if this hasn't reloaded, yeah, this is a great example. So basically a bunch of responses that have similar distances are grouped together. And so it looks for the next jump in distance, and that's where it ends the group that it sends to your response. And so the parameter that auto limit gets is it chooses the number of groups to include in your response. So if I say 1 as only one group to include in my auto limit, and I refresh this application, you'll see quite a different response. So I searched white cars. And so we see that we only have 4 responses, which means the other responses didn't make the cut, meaning after this response, we had a huge jump in distance, which means that item is less relevant to us, and so we leave it out. If we change this to auto limit of 2, and we search white cars again, we see that the number of responses has grown a bit. Oh, I sort of have a dead scroll there. But you could see now that the number of responses increases. We have about 6 responses, which is not how it was before. And we could keep doing that. So 3 cars. So auto limit of 3, and we search white cars again. And now we see we get other responses that aren't really relevant. And so this is just something really cool that WeAreDevelopers helps you, that WeAreDevelopers adds to help you give better results that are more relevant. Okay, I don't think anyone's here to see how text works or how text search works over images, no matter how cool it is. Let's go to the image portion of our application. Right. So in our API folder, we have an API that takes in post requests, and it's pretty similar to how the other one works, where we're using our WeAreDevelopers client, our TypeScript client, we're initializing a connection to WeAreDevelopers Cloud. But really interestingly here, because this is a post request, or rather a server route that's sort of made to read post requests, we sort of read the body of these post requests, which we send from the front end as the base 64 representation of an image, because that is the format that WeAreDevelopers needs to understand images and other media files. So we would get our collection. You could think of that as a table, like I mentioned before. And really important, you can see that the function, or rather the method that we're using now, is called near image, because we're taking images as input. And so in these 5 or 6 lines of code, basically, we're able to have this functionality where our websites can understand that we're inputting an image and then processing that image and giving back relevant responses. So that is literally how this image search functionality works. And so I can get this, and I have a bunch of other things. This is an image of a bird. I'm not sure if I can zoom in here. It's fine. I think this is somewhat big enough. So I get this image of a bird, And you could see here, I get other images of birds because there's an understanding of this is what I want. Now, this is in a pet shopping website, so I'm not going to buy any of these birds. And I can just clear this so there's no confusion. And I could do the same thing with like a dog, for example. And then you see we get back a bunch of other dogs also. If I was in the market for a new best friend, maybe I would add one. But here the idea is just to give you inspiration for possible use case of vision for your websites. This is also me searching through my laptop's images. One thing you could actually do, if I wasn't using my webcam to actually stream and talk to you, I could actually connect my webcam and look at random items on my desk and search for those items in a possible database. So imagine you're an e-commerce website that does fashion and you have a product catalog with a bunch of different products. I could get my phone, ask my friend what they're wearing. If I like it, take a picture of it, and then search through that product catalog to actually purchase that thing that my friend's wearing. And so this is the idea of vision. And of course, you can absolutely expand this beyond buying things. You can use this for fun, for searching through maps, for directions, for instructions, for education. Like the use cases are somewhat endless. And I guess that's the idea behind this talk. It's to sort of give you somewhat inspiration to go out and see what is possible. And so yeah, this was my talk, Vision for Front Ends. I hope you found this extremely useful. If you'd like a link to the project that I just showed, please scan the QR code and you'll find the link to not just the project, but a bunch of other really interesting resources. I have another multi-modal app that I use to find my Friday movie night idea. And so I take a picture of a random object, and based off that picture, it sort of cross-references that across different movie titles that exist, and then it gives me a movie recommendation to watch for the night. And so this is another idea of like giving your front ends vision. And maybe this is an application that I could actually share for everyone to use if you have that problem of hey, what should I watch tonight? But this is the idea. Vision for front ends does not have to be extremely tedious or extremely painstaking or difficult. It could be as straightforward as a couple lines of code. And I hope this sort of gives you a better idea of how you can achieve that. I've been Daniel. Thank you very much for listening.
That was excellent. Thank you so much. This was really good. Yeah, it's an interesting bit to actually search by topic and get the right videos and images back and these kind of things. One thing that always worries me is that when it's built into the browser, and the Gemini model is now going to be built into Chrome soon, and also Edge is going to put their own stuff in there. A lot of people are just like, for years I've been a very big advocate for accessibility and said like, okay, images should have a proper description and actually make sure that they're searchable that way. That's great for SEO as well. And now everybody's like, yeah, but machines can take a look at it and actually do something and do that automatically for me. And it just there's still this like error margin in there that you will get images described for a blind person as something completely what it's not.
Yep.
And I think that's the real worry. I like the concept of like extending search for things the way you showed it much better, rather than like hoping that automatically magic happens when you get things described, or like automatic captioning of videos doesn't work the way it actually should be yet either.
Yes.
And that's also a comparison thing. The data set that's it's trained on is the biggest thing that I found is the issue there. One thing I miss is also transparency. Like all these models exist, but you don't know what they've been trained on. And actually, Leon was the only open one, and they just basically removed all the illegal content that they used to have because it was so open. So that's the worrying bit, that basically you don't know what's in there, and you just hope for the best to find these things. And what would you recommend to make sure that the content that when you just, for example, looked for birds and you got the flying pigs, what could you do to actually prevent these kind of things from happening?
Or also thank you for bringing up those very, very valid points. First of all, like the one on accessibility, incredible, because one thing that we do as a team is we like to strip things bare bones, and so this application is like we like to test the limits of models, and so there's literally 0 meta tags, and that's the way we put that out there. In an actual production use case, if you want to get the best out of your models, you want to annotate your images, right? Like it absolutely helps. You can't 100% rely on these models to like predict with 100% accuracy. I don't think there's any model that across a large data set can do that. And so you always want to be able to help, not just for the models, but also, like you said, accessibility is an incredible use case. And also not all applications need AI like that. And there's applications that actually benefit from having as much information from images as possible, which in the end will also benefit not just humans, but also AI systems trying to process them. And also the case of not knowing what models are trained on is a really interesting one. And so you have a lot of these big tech companies, which I know a couple are, having legal troubles with that problem. And I think the beautiful thing is you can train your own classifiers, which I'm starting to see a lot of much smaller models, much more topical models, which, not to say the others aren't ethically sourced, but, with, no open court cases on where that data came from, which are also more industry specific, start to sort of take rise. So if this is like a specific model that is like a not safe for work filter that's been trained on open data, and so I'm starting to see a bunch of different really interesting models from some smaller companies do that. I can't think of any off the top of my head that I would recommend, but I will take note and share a couple as I see them. But yeah, no, that you raise a great point. You really have to be wary of what information is being used to train these models, and also you can make use of fine tuning if it doesn't necessarily work for what your use case is. You can make it work.
Yeah. I also like asking my friend what they're wearing is probably not a good thing to start a conversation. But like, it's what I love is when these things come and you don't expect them. I mean, like for example, macOS over the last, and also Windows over the last few iterations just had lots of that stuff in there. Like you use Quick Look, or you use you do search on the operating system, and you find images with that content in there, and also with that text in there. So that's the interesting thing, that actually these the operating systems under the hood do these kind of things. I mean, what fascinates me about, for example, when you use a preview, when you use preview on a Mac like this one here, that actually it used to be just like, okay, that's an image and you can crop it and all kind of things. But you can now just basically say like, okay, I want text selection, and you just copy and paste the text, and it's not an issue at all any longer. What I found the other day is like Command-Shift-K is a keyboard shortcut to get rid of the background. Oh. And it's not documented. It's like it's just in there.
I did not know. So I did not know there was a keyboard shortcut. I did know that there was, you could like right click and take the background out. But like I think that's the point also of a talk like this. It's to democratize a lot of these features. When you watch these large keynotes of like these big tech companies doing these incredible things, I don't know if I think anyone with like an Android or an iPhone knows that you could search for items in your gallery, right? If you take a lot of pictures, it's kind of hard to find things. You could search for your passport number, and if you took a picture of your passport, that comes up. And all of that functionality previously has been sort of gate-kept and kept proprietary to a lot of these organizations. But with these embedding models that are being released, both by the companies and a lot of these smaller models, you have this functionality not just kept for these, very sort of very restricted platforms, because when we think about it, not a lot of people have the higher end iPhones or the higher end Google phones, and then having these on a platform like the web really has all of these things accessible to so many more people. So I find it really incredible that we're able to have these things today.
Yeah, Google Photos had that for quite a while as well. And it's interestingly enough, it actually does it with, okay, my phone just opened saying try Gemini because I said Google Photos. That's creepy. But you can even use in other languages. You can do like chien in French or like a Hund in German, and it finds pictures of dogs. So
Yep.
actually, it's really interesting how it actually does that inflection into other languages for you.
Yep.
That I found always very useful. The search on Mac is like, show me all files that are older than 1 week, and it will find these for you. And
Yep.
these are the things that it's just like, and I love that if we can, you can either say like that's a feature of your product, or you can just put it in and let people find it themselves.
Yep.
And I think that's the really the powerful thing, that by using the interfaces more, you can actually get better with that. I always dream of an interface that like finds out if I do the same step 3 times, it gives me a button for it.
Yeah.
You know, that like the machine learns from my interaction and not just like gives me an interaction that they hopes is the right thing to do.
Yeah.
And of course, you showed pictures now, but video is even more interesting, that you can basically have a 2-hour video and say like, where does the donkey come into the picture? And then basically it gives you the timestamp of that one. So that's another one to do that. Like that of course is a different data set, but it's when you showed, for example, the Soma generating things, one of the things that creeps me out is always the bad cuts after 4 seconds, because all these products basically create 4-second videos and stitch them together.
Yeah.
So you always see that little frame and you're like, okay, that now I know it's AI generated. So these are the things
there's
that,
signs. At least there's signs that, you know, it's AI generated. That's really interesting. I didn't know you would be interested in something like, you know, when does the donkey show up in the video? Because that's absolutely something that that I've built that I should probably write a blog post about and be like, hey, look at how this works. And I think, you know, it sounds like a lot of people would like that.
well, we do a lot with the videos of the conference that we have right now, where it like you do the auto captioning and seeing which speaker is when on screen kind of thing.
Mhm.
So and I mean, there's tools for that as well that shows you like, okay, there's 40% that person, 20% that person. And let's not even get started what's happening on live television these days. Like during the Euro Cup, it's absolutely insane what kind of information all these cameras have in a football stadium, and when you can actually see which player was where and was the offside and what was going on there. And I remember a few years ago they tried to track the ball, and they had like a referee that had a bald head, and it was actually him recording that referee rather than the ball for half the game. So that's the errors that we have to learn from. But it's just incredible what information is there. Of course, the energy consumption and where the data goes is, of course, the problem there. But as you showed, you can host the things yourself and actually do it on device as well, rather than having to go to the cloud and have like the lag of that. So
Yeah, exactly.
there's so many things we can build with that. It's really, really exciting. And voice recognition, that always cracks me up, that people were like, okay, and I want to talk to my computer. And you're like, yeah, and if 50 people in the same office do it, it's not going to be very effective, is it? Like,
I think like the you know, the really popular example is I don't know if you've seen that there was one TV show where someone said the words no one is supposed to say, hey, followed by Google. And then because it was a really popular TV show, everyone's phones exploded and we're like, hey, what would you like Google to do? It's like that's the example of like, you know, like having the right time for AI to sort of jump in. I know, yeah, voice is also a really interesting modality. And I actually gave a talk on something similar yesterday, where the idea is, when we think about AI right now, we think about AI as these like large models, right? We're like, oh, GPT 4.0 or GPT. I think there's a new one called Strawberry or something. And there's a lot of really smart people in the AI space who basically come up with the idea or the hypothesis, or the observation rather, that going forward, advancements in terms of great applications or great use cases or experiences with AI won't come from using these large models individually, but will come from like a collection of interactions that multiple models feed into each other. And so you have, and so this is also leaning on the idea of multimodality that I was sharing, where you could have a voice model sort of listen to what your voice is saying and then generate an image or some sort of audio, and then maybe that audio has like code. I mean, that video has like code or something in it, and so you have all these different modalities sort of feeding into each other. And so I think that will also help you out, like you just gave that example of, hey, if I do something 3 times, I want the AI to create like a button for me and be like, there's a better way you could do that. And so with these computational systems that people are thinking about, with these different AI models coming together, I think that's soon to be a reality. And I'm extremely excited to explore how we can like leverage things like that on the web, because I just think it's a much more accessible platform than keeping things on specific devices.
Yeah, next week we have a security live day, and there's another interesting space with like voice mimicking and fake deep fake videos and all kind of interesting things in that space as well. It's like the amount of times where a voice recognition was basically a login system, which was a 1980s thing. And I mean, they can be faked these days so easily. It's really, really terrible. But yeah, I love that you're trying to bring that into the web. The only issue that I also find with it is like it's very much that if it's not on device, and I was part of the W3C group on device AI learning, machine learning, then you're basically beholden to either Google or Microsoft or whoever else is the browser provider as well. So we always said like browsers should not listen to keystrokes, browsers should not listen to your mouse movements, and now we're like, hey, AI, and now the browser listens to everything what we're doing.
Yeah, I think like with AI being in the common conversation now, a lot of people are working with things like WebAssembly, where you have a lot of these AI models that sort of like are built directly and work through platforms like like WASM and then run natively on the web, which is an interesting approach. I haven't seen anything sort of concretely production ready yet, but it's also a space to watch out for. But no, it's right. There are definitely security concerns when you think about where that data actually is and who is the owner, who's the actual owner of that data. But yeah, time will tell.
Ford just had a patent that they actually filed to have your car listen to you and show you products that you might want to buy while you're driving. And that is just that is a patent. First of all, it's fascinating me, and second of all, no, you're driving. You shouldn't be buying things while you drive. This is just completely going in the wrong direction.
To be honest, I feel like car manufacturers are not the best. I think I saw a subscription for like they have subscriptions for everything. Like at some point, I think we'll have subscriptions for blinkers. Like, do you want blinkers on your car?
Well, BMW drivers never used those before anyway, so it really doesn't make a difference.
Maybe they didn't buy that option.
Well, I mean, I could talk to you for hours, and we will. I think there's lots of stuff that we can do more about this. But for now, I think that's the time that we have allotted for this, because we're going for the next Code 100 challenge and finish the day off. So thanks so much for this talk. This was really cool, and lots of comments that people were excited about it as well. So hopefully we'll see more of those, and we're going to edit the video, and then you can play with the tools that you've done. And yeah, it's going to be interesting to see. Thank you so much. This was great.
Thank you so much, Chris, and thanks everyone for watching.
Cool. And that's the end of the day, as we didn't have the other talk. Normally we thought about the live format, changing it a bit to have like a panel at the end with all the speakers, but we haven't introduced that to the speakers yet, so we didn't want to do it this time, so maybe one of the next times. If you, again, please comment and please talk to us about how you like that format, if you like it better or not. There's going to be a blog post about it as well, what else we could do about that. But let's now finish with the Code 100 challenge that I'm going to give to you as homework. So this challenge, you now have time until Monday to actually play with and actually give us the results. And this is what it is. So let me share my screen. this is the challenge. And that one is available at this URL, which is going to be available for you in a sec here as well. And we're going to implement that. But you just go to puzzlescode100.dev, and then we see the Congress data thing there as well. What I have here is a data set of all the videos that we gave at the Congress, that we had at the Congress, which is like a lot of videos. I'm not going to say how many, because one of the things I want you to find out. So we get this data, you get this data set here, which is a JSON data set, which I want to give a shout out to my former team at Microsoft who did that JSON displayer in the browser. So this is Edge showing JSON. So you see here now, this is 10,000 lines of JSON with lots and lots of information about all the talks that we've been having at the Congress. They all have a title, a description, stream provider, start date, and so on and so forth. And I could have gone completely wild with that, but this is basically what I want from you. I want you to help me analyzing that a bit and actually give me some data from that data set. You can also browse the data if you want to. So if you actually don't want to read the JSON to find out about things, you can actually click it through here. Then you see the speakers here and the information about that. This is just basically HTML, and you can also do a search that automatically would do like, okay, so let's search for Intel, and it would automatically find the right thing that we have here, the content of that as well. But it's just for you to give you an information what the data is like, and the JSON object gives you the structure of that data. What I want from you is a few things. I want to have the overall amount of sessions as sessions, the stream sessions, which are the ones that actually had a stream provider. More than one speaker is going to be the amount of talks that had more than one speaker and not only one. Then there's going to be types, which should be an array of all the types of sessions without repeats, because there's basically tons of them that are the same. And the longest title, the one that has the longest title of the talk and what the longest title was, so the sentence basically. And the average title length, like how long was the average amount of characters of the title. And I want that back as a JSON object. So in this case, sessions 300, stream sessions 100, more than one speaker 20, types, keynote, random waffling, mosh pit, virtual talk, longest title, and the average title length. And you can submit this form by Friday, or actually, let's change it to Monday so you have a bit more time in case you want to do something on the weekend. And here's the form where you can send it in. And then we're going to pick the winner from that and announce it on Monday, who's going to be the lucky person to join us at the final of the Code 100 in July next year in Berlin. And I'm going to send that out from the WeAreDevelopers Twitter account soon as well, so everybody can take part. And hopefully you will find the right answer. And I see on Monday what you sent in. And with that, I want to thank all the speakers that we had. And I want to thank you for watching. And hopefully we see you next week at the Security and Data Live Day. And yeah, until then, I see you soon. Bye-bye.